Yeah. Uh, just a minute. We'll just wait for another 1 or 2 minutes so that all of us can join and we can start with.
Oh,
So, how is preparation going on for all of
uh,
you?
it's good.
Viraj?
It's good, sir.
Yeah, it's going good. Okay.
Yeah.
So, you're a qualifier student.
Yes, I'm qualified student.
What about like, are you done with all weeks? Maths 1, 2, 3,
Yes,
4.
yes, I have done.
Which is the most difficult week?
Not much difficult. I
Yeah.
I don't get any difficulty in this math
All right. Good.
because I have like a math background in 12th, 11, 12, so that's why.
That should be fine then. What about others?
Week 1 to 4, all are fine, sir. But after that, things are getting a little tough, but that's fine. And in logarithms part, I think not much importance was given to graphs.
Okay.
As they have given in earlier sessions like quadratic or exponential functions, that much of importance was not given to graphs of logarithms. So we had
But why
to
focus on
fail.
logarithm in your qualifier, in your quiz 1? That is not coming. The syllabus is
Yeah,
week 1 to 4.
that's
Okay,
definitely
like on
not coming
general.
in qualifier.
Okay.
I'm just telling about all the syllabus till now.
And
Okay,
that's
so
that's
but
what it
again,
is.
if it is not there in the lecture, we don't have to assume that it won't be questions from there because there is certainly questions from logarithm.
Yes,
In your, yeah, so graphing is definitely important, and if we will be taking live sessions where we'll teach you how what we are doing. Okay,
yes.
yeah.
Sir, I have a doubt, like a question. I have question.
So doubts and all we'll keep it at the end. We'll just go with
No,
our
sir. In
okay,
this,
like
like exams on the point of view. My
okay.
question. So,
Mm-hmm.
which week will be more weightage in this examination?
Okay, I'll discuss all that in a minute. So we can just wait for all of us to join here. I think yeah, some probably 4 of us are here, but we can just wait for another 1 or 2 minutes. Okay.
Okay.
Yeah.
Actually, sir,
Do we have
CT
negative
class is
marks?
going on. So,
Yeah, I guess yeah. It is still going on, is it?
yes, sir.
Mm-hmm. Fine, we can wait for another 5 minutes, and we'll try to cover soon because I cover soon in the sense what is the most important. We'll discuss that. Okay. So what about others? Like, how are you feeling with maths preparation? Are you done? Struggling somewhere? Any concepts which is really haunting you in some sense? How is it? Like anybody? Whoever are good, do not say, okay, it is easy and all that. I'm asking whoever is facing difficulty. Week 4 is little bit. Okay. Aditya says. So Aditya, I'll say like, Aditya, for me, like if you are to ask me, and if you know the graphing parts, if you love the graphings, you will like week 4 a lot, right? So maybe if you don't know how to graph any functions, like a polynomial function or something, then you might find difficult. Okay.
Sir,
Some of
can
you says
we,
SSC.
sir, today can we do like previous year questions of qualifiers?
Previous year qualifier. So your basically your mock week 1 to 4, whichever was given to you this time, mock 3 basically. Mock 3 is a qualifier paper basically. Yeah,
Okay,
there
sir.
was a typo in the portal though, but ignore like question number 12 was
Yeah.
16. There was a typo, but
Hmm.
ignore that. And I think in the solution PDF it's given properly. And some of you might in the previous session were complaining about this, and also the solution where the question was not matching with the solution, right? The solution question. It's just because qualifier papers are generally there are multiple sets for it, right? So we just took one set of it and we have prepared the solution. So it's like that. But the approach for solving any of those questions are similar, what is given in the solution, right? So you can apply the same approach. Hmm?
Sir, I find a little
Right,
difficult
sir.
in
In which
determining if the function is injective or surjective.
I get it, yeah. So Kirti, right?
Yeah.
Okay. Kirti, don't worry about it. It's about mostly the foundation comes from week 1. Even if you don't know that much with your this thing today, when we are discussing about this week 3 and week 4, I'll give you graphical intuitions of this week. Okay.
Okay, sir. Thank you.
That. Uh, what about others? Tell me where are you struggling. So basically, if you put it in the chat window, I won't be able to read it and I won't be able to reply. So you can just directly ask me. And other thing is, when you're putting something in the chat, make sure it is something relevant to our quiz.
Sir.
Because it might be disturbing others when the chat pops always, right? So make sure to avoid chat as much as possible until or unless needed. Let's say if I'm asking question and I ask you, okay, could you tell me the answer for this? Then you can use your chat window and answer, okay? So let's keep it that way so that, you know, the others don't get disturbed because the chat things keeps popping. Let's concentrate. And this is like last minute study because it's today and then tomorrow you have to, it's just tomorrow you'll get a self-study time, right? So my duty is to tell you what to study and, you know, where you should actually focus more. That is something I'll deliver here. So,
Sir,
Yes, sir, definitely.
hello, sir. Am I audible?
yes, Pushkar, right?
Sir,
What's
this
your
is
good name?
Satya.
Okay, Satya, yes, please.
Sir, will you take a log class, sir? Because every week
Logarithm?
on Thursday, you make the weeks, I mean, you make it easy for us. Every week's chapter and all that. So this week, there was no logarithm class. I mean,
Exactly, yeah.
the week.
So it is after your qualifier. So I think it's from Tuesday. Your classes will be from Tuesday, and that's going to start from I think yeah, Tuesday, Wednesday, Thursday. It's like this, and then Friday is your deadline.
Will you take, I mean, the
I'll be
log?
taking any one of the session. Yes.
Okay, sir.
Yeah.
Then it's a relief. Thank you, sir.
Hello, sir.
Yes, sir, we enjoyed your session.
Yeah.
So
Thanks.
I have a
Yeah.
problem in maxima and minimum value.
Of a quadratic function or polynomial function, something like that. Okay. So if you have a problem with this, I'll just give you an idea when we are dealing with. So this maxima and minima value, as if now it comes only for your quadratic functions, right?
Yes.
Okay. So could you tell me just right away? I'll ask you a question. So do not worry others. It's just that you can say this is warm-up time going on, so that others can join. So just think of like if you have a parabola which is opening upward. Okay. Where will be the minimum value be?
At the vertex.
At the vertex. So when the parabola is opening upward, do you think the minima value exists?
Yes, sir.
What about the maxima value?
No,
Where will
it
that
will
be?
not.
It exists.
Yeah.
It
So
exists
somewhere
when
it will
the
be it.
parabola
Infinite.
Right? So you got
is
it, right?
downward.
Yeah. So if I have to ask you what about the polynomial? So it's really hard to say what is a maxima and minima value as if now. But this is certainly you can tell it when you are entering calculus part, where you can tell okay what is the maximum value and what is the minimum value, what is the point of
finding
minima,
the
maxima, and all that
derivative.
things. Yeah. So you need some calculus tool there, which we will definitely learn. Okay. So don't worry about that thing. Okay. So that is all. But for polynomial, you don't have something like maximum or minimum. Yes, Shubhangi?
I went once, question number 10.
Okay, so this way we are not going to entertain for today's class because this is something revision. Okay.
Yes.
So we are not going to take up questions like this. We'll see if we have time at the end. We'll take up questions that way. Okay.
Sir, you will be dealing with concepts right now, right?
Concept and summarizing the things. Basically, today is summary session. So I'll be telling you, okay, this is what you have to go through. So mainly I'll be telling you what is on week 3 and 4 because week 1 and 2 is done. But we'll see again where all, because we know what is there in the question paper, right? So we also know, okay, where you really have to put emphasis to. So we will just summarize those concepts. So it's not like, it'll be more like, okay, this is what it is there you have studied, right? It'll be more like this. It's like all of us interacting here, maybe not all of us, me talking more and you listening to me. And it's just that me emphasizing on certain topics, which is really, really important like that. Okay.
Okay.
So
Thank you.
So we'll just brush up here. And my method of teaching is whenever I'm telling you something, whenever I'm teaching a concept, I will give you a question for sure. Okay. So it's never, just concepts. So you will have questions for sure when I'm discussing. Okay.
That's what it makes you little interactive and best, one of the best teachers.
So thanks. Well, that's what we'll do. Okay. So that's how we should go. Okay. So what about, okay, I think, should we wait for some more time? CT sessions got over or it is still going on?
It is still going on.
Sir, I think we should start. Others will recording.
Okay.
Yes, sir.
Sure. So I'll just share my screen because it's already 10 and And as we know, we are allotted with 2 hours. So we can just go ahead. So all of you, please mute by yourself and, let me not mute you guys. So you can see my screen.
No, sir.
Yes, sir.
Now
Yes, sir.
slowly you can see this. Okay, so again, this might be some general discussions here, but it's okay. This is good that we can just discuss in beginning what is really important, and pardon my bad handwriting, but yeah. So you see this, first let me start with the weightage, because this is where we all are, we want to know. So you see, since I'm dealing with week 3 and week 4, so weightage is roughly 30% for this and 30% for your week 4. Okay, so in total, how many? It's like it's account for 60%. And now if you are to ask me among week 1 and week 2, which is the most important week, I would say this. Okay, so now you can understand, like, okay, if this is the most important, that means it has got some weightage. I don't want to tell you how much in figure, but yes, roughly you can say, like, yeah, 25% maybe, and this might be like 15%. So which makes it how much? 30 plus 40. So this is what, like, roughly I can say. Okay, fine. So all of you okay with this? Now you got some idea like how you have to strategize your preparations.
Yes, sir.
So can you repeat the network issue?
Okay, fine. So what I was telling you is week 3 is roughly 30%, week 4 is roughly 30% again, and this makes it total of 60%. So what we are going to discuss today is more like that. So it's like the most important weeks we are discussing. And week 1 is roughly like 25%, and week 2 is like 15%, you can say, because it's very straight line concepts, right? Like very straightforward questions are there. So we don't, right? So it's like all you have to know is formula. That's it. It's more like, in second week, we are testing your memory, how much you can keep formulas with you. So it's more like that. Okay. So now coming to this week 3 and week 4, what really is important? Okay. So this graphing part is really, really, really important for week 3 and for week 4, for both itself. Okay, so we'll discuss all these, like in week 3 is all about quadratics, right? So what are the various terms, each coefficient, what does it represents, how do you draw the parabola, upward, downward, all that things. Okay, then what is the slope for this quadratic equations, or basically a quadratic functions, right? Then you have this concept of SSE, which was introduced in your week 3, sorry, week 2, but it has got its importance in other weeks as well. So you can see in week 3 also somewhere SSE is coming up, right? And then there is something like reflections of quadratic functions. Like, let's say if you have given a parabola or something like this, then how is the reflections for this? So we can just look at this when we are dealing with the graphings itself. So in the graphing itself, I'll tell you most of the things, what are the things here, okay? Likewise, when we go to week 4, we'll be discussing, we'll first start with the graphings, okay? And then there are some, in graphings, what do you really study? Then there are various concepts like, okay, what is turning point? What is multiplicities, right? Then the points where the slope is 0, right? Then in what interval it is increasing type, and in what interval it is decreasing type, whether the function, whether this polynomial is one-to-one function, or does this represent onto, like these kind of questions. Okay, so we'll take up all these here. So that is something when I'm dealing with the graph itself, then I'll be discussing all this. Do pay attention for these, okay? Trust me, when you go, I mean, this is something really going to be very important. When you'll see your question paper there, you will be like, yeah, fine. You will be thanking all of us here who are here and who will be interacting here. So that's how it's going to be. Like the graphing is the most important, and that is something you should take away from this session also. That is, you should, even if you don't know graphings, but I assume most of you know. And if you know, just think that I'm just revising you here. Okay, there are certain word related problems. I have one word related problem which I'll discuss with you. Then definitely what are the type of functions, that is what I meant, like 1 1 on 2, right? All these kind of things. That's it. Whether bijective, right? So these are the things. Well, this we can just discuss with the graphs. Okay, so these are the rough things. Okay, so now I think we can start our main subject here. So now starting with week 3, still CT is going on. Still CT is
Yes,
going
sir. Yes, it's
Yes, sir.
Okay, so
Sir, can you
one
request them to record that session?
CT, I think it's being recorded. This is not being recorded.
It is recording.
No,
Yeah,
this is recorded. They're telling
both
ki,
are recording. Both are recording.
Both are recorded.
And
no,
it
sir,
will
sir was
it
telling
will
that ki,
continue, sir.
Sorry.
There'll be another session on CT after that. I mean, it will continue, and they will record that also.
Yeah. Fine, fine. So yeah, since they are doing that, so we can just focus here now. Okay. So we'll just give heading week 3. So all of you, you know that what is first quadratic function, right? How it is like, how do we write it in general form? So it's like ax square plus bx plus c, where a is not equals to 0, right? And we all of us know if a is equals to 0, then this quadratic function is no more a quadratic function, it becomes a linear function, right? Because these terms get vanished and we'll just left with bx plus c, right? So that's how it is. Well, if this is a quadratic function, then what more we can do with this? So all of you please mute yourself. Whenever you unmute, please mute thereafter, okay? So that others don't get disturbed, fine? So now let's discuss some of the, now keep this in mind, whatever is this a is called as leading coefficient. Basically this term we will be using, this a is called as leading coefficient, and the rest all are coefficient of those variables. Now if I have to ask you what is a coefficient of x square, it's a. What is a coefficient of x, b, and which is the constant term here, it's c, right? So it's like this. Okay, so now having known these, how are these a, b, c determine the quadratic function? So basically let's look at this. So we all of us know when a is, so I can just talk about a and then I'll just try to do all that things that we can do with the a. Okay, so if a is greater than 0, how will this, let's say this is my function f of x is equals to like this. Okay, so it's given like this. So if a is greater than 0, how basically what is the nature of the graph that you get for this quadratic function? It's parabola, right? So parabola, either it will be upward or downward or something like this. Okay, so or whatsoever. Okay, so if a is greater than 0, the parabola opens upward. Okay, so I can just write down parabola opens upward, right? And if a is lesser than 0, then parabola opens downward, right? And what if a is equals to 1? Could you tell me? Parabola opens upward or downward?
Upward.
What if a is equals to 0?
It's
a straight line.
straight line, sir.
Straight line. Linear equation.
Okay, so it becomes a straight line. If that is a straight line, then what is the slope of that straight line?
mx plus mx m
B.
Minus
B.
a by
B.
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 Okay, a is equal to 0. Yeah.
Slope will be B, right? And what is that y-intercept?
C.
Right? So this is just to, bring you to week 2 concept. So, okay, fine. That's all about A. Let's go with the C thing. So C is basically your y-intercept. Okay. So what is C? C is basically, so C can be greater than 0, lesser than 0, or whatever. So if C is basically your y-intercept. Okay. So now if I have to simply draw a parabola, let's say if this is my parabola, fine. And could you tell me whether my y-intercept is positive or negative?
Negative.
Negative.
Right? So this is my C. So C is negative, some values. Okay, so this is my C. So essentially this distance is C, right? So now please mute yourself because I'll be wasting my time to muting all of you. So that's what, okay, I'll mute you all. Okay, so this is about, so we are done with this first coefficient, we are done with this second coefficient. So as if now you see this B has, in itself, it does not have a rule, but B with the combination of A has got some rule. Okay, so now I'll just tell you that not B alone, but I'll just write down what B, but B goes always with the combination B by 2A. Now what is this B by 2A? B by 2A is also called as axis of symmetry.
Vertex. Axis of symmetry.
Now, okay, so this, with this, see, if this is my parabola opens upward or parabola opens downward, that is something we know. We also got to know, okay, what is this y-intercept? Yes, 1 minute. Yeah.
So it's minus b by 2a, right?
Yeah. Sir. So it's minus b by 2a. So maybe I can just put it in a bracket to highlight this. So note this, that basically what we were talking was like the parabola opens upward and downward is determined by A, C determines the y-intercept, and B is something telling me about whether it is on the left hand side or the right hand side. Could you tell me whether you know that axis of symmetry is basically a line, right, which passes through the vertex, right, which passes through the vertex. Now could you tell me whether this is called as axis of symmetry? Okay, this is called as axis of symmetry, and it is always represented something as x is equals to minus b by 2a. So note this is x is equals to minus b by 2a. Since this is x, so therefore it will be a vertical line, right? So now you understand this. Could you tell me whether the axis of symmetry of this particular curve is on the left hand side or on the right hand side of the y-axis?
Left hand side.
Left hand side. So now what determines that really? So you see this, basically this left hand side and right hand side is something talking this, basically you get to know through this axis of symmetry, right? So if you know what is the axis of symmetry, you can tell, okay, this parabola, the axis of symmetry is on the left hand side or on the right hand side. So we can talk about the movement along the x-axis, whether it is on the left hand side or on the right hand side. So this is what we get through this minus b by 2a, okay? So now if I have to quickly tell you, if I randomly draw any curve like this, okay, so maybe not this, but let's say, okay, if I have to simply draw this curve like this, okay, considering this is my vertex, what is the axis of symmetry for this?
Y-axis.
Y-axis.
In terms of x?
Minus b by 2a.
Minus b by 2a, but
X
what will be the
equals
value?
0.
X equal to 0.
0.
Exactly. So that is what you get. So that
0.
means minus b by 2a is equals to 0, which implies a cannot be 0 for sure, right? Which implies b is equals to 0.
B is equal to 0.
Right?
Yes, sir.
Right? So this implies b is equals to 0. So when do you say the axis of symmetry is basically y-axis? When b is equals to 0. So you will find all those equations, something like this, f of x is equals to, let's say, 5x square plus 2. Now you look at this. What is the coefficient of b here?
0.
Exactly. So if that is 0, that means my axis of
Zero.
basically, yeah, fine, I got it.
Y-axis.
So, okay. So basically, just by looking at the equation, now you can tell, okay, the axis of symmetry is y-axis or x is equals to 0, right? So all that thing is fine till here. I will not tell
Yes,
you more
sir.
about the movement, whether in on the left hand side or on the right hand side or something like this. Okay. I think we have dealt it when we were.
Okay.
Okay, so when I'm asking you something, then it will be good that if you reply. But when I'm teaching, please make sure that you guys are not talking, because that will disturb others. Okay, so that is, we got to know about ABC rule. Fine.
Excuse me, sir.
Yes.
So just generally asking, this axis of symmetry is also the derivative of the function, right?
How can you say that?
The axis of symmetry is also the derivative of the function, right?
No, the derivative of the function is basically the slope equation, the slope what you get, right? 2ax plus b.
Okay.
Right?
Yeah, by equating that slope to 0, we get this axis of symmetry, right?
No, not exactly. Because you see this, 2ax plus b. Okay, you mean to say when you're equating this to
Is equal
0.
to 0.
Okay, so why do you say
Then
so?
x.
Could you tell me?
Because at the vertex, the slope is 0.
Okay. Okay, so if that is the case, then that could be at anywhere, right? 2ax plus b is equals to 0. This could be at anywhere, but again, you cannot. Okay, so maybe I misunderstood here. I was thinking that axis of symmetry is basically y-axis you guys are claiming, but this is right. As you are telling that axis of symmetry is minus b by 2a. So, well, this is right. The slope is basically 0 at this point of time. It's just because you look at this curve. As you guys highlighted this, so maybe I can just discuss the next concept, that is slope, okay? And we can just elaborate on this. So how is this slope given? Slope formula is 2x plus b. And how are we getting this? Let's not dwell into this. We will discuss this more when we are discussing basically calculus part, okay? Otherwise, if you really want to know how we got this, you can watch Sir's video, Professor Nilay's video. Nilay Sir's video, you can understand this.
I think we can got it by differentiating.
Exactly, but if you don't know how to differentiate, because there are many who are working professional and who are non-maths background, so don't worry
Okay,
about
sir.
this, how we are getting it. The slope is given by this. Okay,
Okay,
so
sir.
now if I
Okay,
have
sir.
to tell you one equation, let me just give you an idea what do we really mean by it. Okay, so for an example, let me say if f of x is equals to 5x square plus 2x plus 1, what is the slope? The question is, what is the slope of f of x at x equals to 1? So could you tell me this?
12.
It's 12.
So how do you do this? So basically what
12.
we from here we understood this is A, this is B, and this is C, right? All I have to do is just substitute here. So 2, what is my A value? That is 5. Okay. They're asking at x equals to 1, right? So I'll just have to substitute it here. And B is nothing but 2. So if I substitute all of these, what do I get?
12.
12. So the slope of this function f of x at x equals to 1 is 12. So notice this one thing. The slope of this, basically when we had a straight line, we had what? Only one slope for that particular straight line equation, right? Or a straight line, a function, let's say function. Okay. So what did you see that? So there was just one slope, but as you are going to a quadratic, there are multiple slopes. So that means the slope at this point is different, slope at this point is different, slope at this point is different, at this point. So at every places, the slope is varying. It is not constant, right? And how it is varying? It is varying in this form, 2ax plus b, right? Okay. So now could you tell me, look at this one thing. There is only one place in this entire in this entire parabola where the slope is 0. Could you tell me which is that place?
Vertex.
Vertex.
So there is only one place in this entire parabola where the slope is 0, and that is the vertex. So basically, if I have to draw the now this represents a vertex. So how will the parabola? How will the slope line look like? Basically, how will this is the tangent which is passing through this, and you will find out the slope for this, and this is going to be okay. So if you want to identify, how do we get this? So now all you can do is we have to find out the place where this is 0, right? So where do you get this? So if I have to say this, now this is my slope 2ax plus b. I'm saying the slope is 0 at which place, right? So all I have to do is just substitute to 0, right? Because this gives me slope, and I'm saying at which place the slope is 0, right? So if I equate this, I get what? X is equals to
minus b by 2a.
Minus b by 2a.
Minus b by 2a.
So at this place, minus b by 2a is basically your axis of symmetry, isn't it? Axis of symmetry. So basically your axis of symmetry is the place where your slope value is 0, right? So now, done about the slopes, and we are done about the axis of symmetry. Now look at the other part, and that is something we are discussing. Let's say, what next? Okay, so slope we discussed. Okay, now let's talk about the vertex. Okay, so that we can cover more. So I'll just zoom the screen and I'll just draw the graph here again so that I can always explain you from here. Okay, so basically not this, but like this. Okay, so now look at this. Where is my axis of symmetry? On the left hand side of the y-axis or on the right hand side?
Left hand side.
Left hand.
Left hand.
Okay, so now looking at the graph, could you tell me whether my b is positive or negative?
Positive.
B is positive. Now this gives me what? Now look at this. This is nothing but minus b by 2a, right?
Yes, sir.
A is positive or negative?
Positive.
A is positive because parabola opens upward, right?
Yeah.
Then B has to be positive for it to be negative, right? Because if B is positive, then
Yes,
means
sir.
overall this is negative, right? So that means if I have to tell any equation something like this, then I have to make sure that B is positive. If B is negative, you can say that no, it's not the right case, right? You can always tell that.
Yes.
Right?
Sir, once again, sir, once again.
Once again? Okay. So now look at this. You know this, what is the equation for this? Minus b by 2a. Right? Axis of symmetry equation is what? Basically minus b by 2a. Right?
Yes,
okay.
sir.
Now
Yes, sir.
what is A? A is positive or negative here?
Positive. Positive.
Positive.
A is
Positive.
positive. Right?
Positive.
What about the x value? Look at this. X value is positive or negative?
Negative.
Negative.
Negative, sir.
B to be negative, what should be the B value?
B value is a negative.
No.
Positive.
No, positive.
If B is negative, then
should be
overall this
negative.
becomes positive.
Yeah, positive.
Right?
Sorry, your voice is little bit low.
Is it fine now?
Yes, sir.
Yes,
sir.
Okay. So that is what? If B is negative, then this entire expression becomes positive, which is not going to be possible because here x is negative. Okay. So I'll mute all again and I'll continue my discussion here. Fine. So now I think I'm done explaining this. So now I can just go ahead and explain you further what is this vertex. So vertex form, basically vertex is this point. So what is vertex? First of all, vertex is a point. Remember this. We always get confused by this. Vertex is a point. And how do we represent a point? By x comma y, right? Now you notice this. In x comma y, what is the x value from here? Minus b by 2a.
Yes.
Right?
Yes.
And if this is my f of x, if I substitute this x value, I will get the other y value from here.
Yes.
That
Yeah.
means if I substitute f of minus b by 2a, I will get the y coordinate for this. So this is the point which vertex represents. Clear?
Okay. Okay,
Clear?
sir. Yeah.
Okay. So now a quick question to all of you. Let me say a question here. 2x square plus 4x plus 5. Could you tell me whether the axis of symmetry is on the left hand side or the right hand side? Quickly.
Left hand side.
Right hand side.
Left
Hand side. How can you say right hand side? I just discussed here.
Left.
Left hand side.
Left hand side.
Because A is positive. Then B has to be positive for it to be on the left hand side. I mean, that is what we were telling. The B has to be positive for it to be on the left hand side. So this is positive, right? So therefore it is on the left hand side. Or even if you didn't get it anything, that's fine. Just find out the vertex, right? Just find out the vertex. Could you tell me what is the vertex for this particular quadratic function?
Minus one.
That is not the vertex. Vertex is the point.
Minus 1, comma 3.
Minus one,
Minus
comma.
1, comma
Minus 1, comma 3.
Minus 2. Minus 2.
Yeah.
Minus 1, comma minus 2. Okay, let's check this out. So what is the formula to get my x value first of all? Minus b by 2a. So what is minus b means minus 4 by 2 times 2, which is making it minus 1. Well, you told this as the right answer. Now we have to find out f of minus b by 2a, that is minus 1. So f of minus 1 is nothing but what? 2 minus 4 plus 5, which makes it how much? 2 plus this will give it
3.
This 3.
Positive 3. That means this is not here. That means this parabola, how it is going to look like?
Open downwards.
Open upwards. But
Okay.
right, it is going to be something here.
Okay. Mm.
Right? So now this is minus 1, comma 3. Okay. So now you understood this?
Touch base.
Okay, I'll come to the x-intercept part in a while, but for time being, understand this. Now you understood this is the vertex. Now, since we are discussing about vertex, let's discuss about one more concept here. This is like quadratic equation in a vertex form. Okay. So quadratic function in a vertex form. Now this is very important. Okay. Because we always tend to forget about this. We don't pay attention to this, but this is important from your examination point of view, or like always. So whatever I'm discussing, it's not, don't think this is not really important. This is really important. And trust me, whatever I'm doing it, just do it multiple times. Okay. And then go for your exam. And believe me, you will be able to do some questions at least. Okay. So this is not, because all of these are interconnected. I cannot just tell you what is vertex just like this without explaining what is the graph for this. Okay. So trust me, and we'll just finish it on time. Okay. So don't worry also about the time and all that. So now look at this quadratic function in a vertex form is given as, let's say, if this is my quadratic function, let me take this point only. Okay. And okay, so if I have to say, I'll take this point itself so that, you know, we verify also whether the equation is right or wrong. Okay. So if I say this is my h comma k. Okay. So what is my axis of symmetry?
minus b upon 2h.
Minus 1 comma
No,
3.
in terms of, look at
X
this.
equal to -1.
H. That's it.
H.
What is my axis of symmetry? X
H.
equals to H. H is my axis of symmetry. That's it. Okay. So that is all fine. Formula and all that things. That is very good. But when we are given a question, we should go now next step ahead. Okay. So now let's understand this. Now, if this is h comma k, then how do I write my quadratic function in a vertex form is something like this. There is a one formula. You just memorize it. Okay, so y minus, I think this is the only formula which you should memorize. Rest all, I don't think so. Yeah, again, you can tell me you have to memorize slope as well and vertex axis of symmetry, but those are very simple things. So how is it written is y minus h is equals to a times, sorry, not h.
Y minus k.
Minus k.
Yes. Thanks for correcting me. So x minus h the whole square. Okay. So now let's verify this. Okay. We know this.
So I
this
think
is,
you derived it from y square is equals to 4x.
okay, so you can tell that, but let's not get into the derivation part and all this. Okay. So now just understand that this is the formula for quadratic function in a vertex form. Okay. So it's not a function though, but it's an equation because we are equating with something here. But let's say this, when we just represent in the terms of f of x equals to something, consider this is a quadratic function. Okay. So now what? Let me say my h is whatever is given here. Minus 1. And let's say k is 3. And okay. So I did not tell what is this a. A is basically a leading term, a leading coefficient. Let me say my a is 2. It can be anything. This is called as leading coefficient. So remember this. Okay. This term will be directly told in the question that, okay, the leading coefficient is 1 or 2 or a 3 or whatever. Okay. So you should be able to understand what is that we are talking about. Leading coefficient is the a value. This is basically the coefficient of x square. Okay. Or whichever is, let's say if a polynomial of a higher degree, let's say x to the power of 5, and if I have to ask you what is the leading coefficient, so whatever is the coefficient of the highest degree of that term is the leading coefficient. Okay. So keep that in mind. Okay. So now let's simply substitute and get the value. Okay. So what is k value here? 3. What is leading coefficient value that we are given? 2. And x minus, what is the h value here? Minus 1. Right? So now we can just simply substitute this and get the value. So this is going to be x plus 2 the whole square. And let me say I'm shifting this to the other side.
X plus 1 the whole square.
Oh yeah, sorry.
Whole square.
Yes. X plus 1 the whole square. Now what? Now we have to expand this. So how do we do this? What is the expansion for this? X square.
X square
plus 2x
Plus
plus
2x plus 1.
1
Plus 3. Okay, so some of you, those who are from non-maths background, how is this we are doing? For you, I would say just memorize the formulas for these things. X plus or minus a the whole square. What is the expansion for this? And what is the expansion for this? Okay, so what is the expansion for this and what is the expansion for this? If you know this much, this will suffice the need. That's it. Okay, so having known this, if I have to expand this further, what do I get? 2x square plus 4x. And if I multiply this with 2 and this 3 will make it 5. So is this the same equation that we are getting? Yes. So that means whatever we are writing in a vertex form is something right. It's not wrong, right? So we can also express it in a vertex form. So if given a vertex and a leading coefficient, we can actually find out the quadratic function, which quadratic function it is, right? So this is the another important concept that we had to discuss, and we discussed it here. Okay, so now let's get into this. Okay, so one more thing I have to discuss here is this x-intercepts. Okay, so let me talk here itself, and then we can get into like what are the types of a function in this, maybe some alterations of the questions here, and then we'll just see how will the.
Sir, one question can I ask? Sir?
Yes, please.
Yeah, if a vertex is given, also y-intercept instead of a, how do we find that?
Could you repeat again?
If the vertex, the coordinates of vertex is given,
okay, let me just
and leading coefficient is not given, instead y-intercept is given.
Oh, that is again interesting. You can do it because you can just keep your a just like this, okay, and you can just simply expand and then find out, okay, what is the leading coefficient, right? Because you see this, when you expand this further, now if I have to tell you, okay, this is my vertex, let me say h minus k is something we are getting, right? So when you expand this, you will see this a term will come as a constant term also, right? when you expand this further, because you see this, if this was my A, let's say, here A plus 3 would have been, right? So let's say I would have got A plus 3 and you are telling it is positive. And let's say you are telling that there is some value, let's say 10. So now you can just simply substitute it here and get the value of A, which maybe comes out to be -7 or something like that. Okay, is that okay? You understood?
Yeah, I understood. Yes.
Okay, so fine.
So
Let's
could
go.
you repeat his question? What exactly
Yes,
did
sir.
he
So
ask?
his question was, let's say,
Why?
correct. What he meant to say was, let's say the vertex is given. Okay, the vertex value is given very finely. Let's say the vertex was given as 2, 3. Okay, and other part which is given is the y-intercept is given. Okay, let's say y-intercept is some value. Let's say it is like something, some value is given. Then how do you find the equation? You understood now? You will do it the same way. Just write it in a vertex form and then express this completely, and whatever is the constant term, you know that constant term is basically your y-intercept, right? You equate it and get the value of your A. That is the leading coefficient. Okay.
So means you are trying to satisfy A in the whole equation. Okay, sir.
Okay, clear? So now let's
Yes,
go
sir.
into the next concept, that is Saranya, do you want to write something on the screen?
No, sir. No, sir. Sorry.
Okay, that's
By
by
mistake.
mistake.
Yeah.
Okay.
Yeah.
All right.
Sorry.
Okay. So x-intercept. So basically, you know what is x-intercept? Wherever the curve cuts the x-axis, right? So what are the other names for x-intercepts? So these are called as roots. So this is
Zero.
these are called as roots or zeros of the function f of x. Okay, so all of you clear with this? So other name for x-intercepts are called as roots, zeros of the functions, zeros of the polynomial function. Okay, so now this is what we had been doing. Like if you are in the school days, we were always asked to find out, okay, what are the roots of this quadratic equation, right? Right? So you should keep in your mind these roots are nothing but x-intercept. So what we were doing at that point of time was we were actually finding out what is x-intercepts. Okay, but maybe I never realized what I was finding when I was in my school days. Like, okay,
Yes,
what
sir,
is
me
this
too.
intercept? Yeah, so basically as you go further, then we realized, okay, this is what they meant. Root means nothing but the x-intercepts, right? Okay, so well, that was my case. I don't know, but how about, of course, there are so many smart guys here who might be knowing, okay, what was that? But that is, since I was one of the weak students, so I'm just telling you, okay, this is something, and those who are weak like me, they can understand, okay, this is what it means. Okay, so x-intercepts are nothing but the roots, and these are also called as the zeros of the function. Okay, so now what do you really mean by this? Okay, so now if I have to tell you, basically, if I simply draw a graph like this, and if I tell you this is -1 and this is 2, if I have to ask you what are the roots for this? Roots for this polynomial function?
Minus 1
and 2.
-1 and 2. Okay, and the other thing, what is the factors of this? Now if I have to, what is the factors of f of x, then what do you
X plus 1 and x minus 2. X plus 1 and x minus 2.
So x plus 1. So how do you write that factor? So basically it's x minus the root value. So this is what you get the factor, right? So what is x minus first root? What it is? -1. What is the other root that we are getting? X minus 2. So now if I simplify this, so this is going to be x plus 1 and this is going to be x minus 2. Okay. Okay. So now those who already are well versed with, those who already know what is a multiplicity, could you tell me what is the multiplicity of -1? The root minus 1.
1, sir.
1.
Multiplicity of 2.
1.
Okay.
1.
So those who already know me, I mean, those who are already doing the graphings with me, they could directly tell me, okay, if this is that root, what is the multiplicity of this root? 1. So it should cross in a linear fashion, right? As you can see, it is crossing in a linear fashion. What about at 2? Again, it will cross in a linear fashion, as you can see from the graph itself, right? Okay. Those who did not understood this, don't worry. We are doing week 4, where you will be able to understand this, okay? And then you can trace back and see, okay, what I was talking about here, okay? So this is just to all those who are actually knowing the graphings, how they can do this. This is how you should do. Okay, so now having known these, what are the roots, zeros and factors? Now you have to tell me, how do you really get these x-intercepts? How do you get these x-intercepts? There are 2 ways, right? Which are those 2 ways?
Factorization.
Y equals 0.
Quadratic.
Just a minute.
Factorization and formula.
Correct.
And
One is this factorization method, right? That is something
Splitting
you are
of
studying.
Factorization.
And this is something I would not tell you how you will do. That is something you should
Square
know.
method.
splitting,
And
completing square method.
you have another ways too, yeah. So, but this is formula method where we say minus
B plus or minus.
Plus or minus
root over a
Square root of b square minus
Square
4ac by 2a.
2a.
So this is the formula method, factorization method. I am not going to elaborate it here. Please watch.
Sridharacharya method.
Yes, Sridharacharya's method. So you can watch that. How is that happening? I'm not going to really tell you because that's very basic thing, and I expect all of you to know how to get that. So these are the two methods by which you can get
the square.
Sorry, what?
What about completing the square?
You can do. I mean, there are so many other methods too. This is another method that, but since in the lecture only these two methods are discussed, that is why I don't want to deviate from the.
I think completing square method is also taught us.
Yeah, that's also discussed.
Okay, so I can just write down that also. Completing square method. Okay, so now this is another method which you can see in the lecture what it is, but do not worry about, in terms of factorizing and all this. I think all of you know what it is, right? So now these are my x-intercepts. So you understood what is first x-intercept and how do we get these x-intercepts value, right? Okay, so now having known this, let's talk about something interesting. This is called discriminant. Discriminant of quadratic equation. So basically you find discriminant for a quadratic equation. That means something has to be equated and then you find out its discriminant. Okay, so now if I say this, how do you get this? Discriminant is generally written as d, and this is given as
b square minus 4.
B square minus 4ac.
Okay, so now you know what is b, a, and all this c and all this. Okay, so now what does this tells you? If d is greater than 0, then what does this implies?
It has real
Real and distinct roots.
Real
Two real roots.
and distinct. Okay, so look at this. There are some keywords that you have to understand. Real. So real means
real numbers.
All real values. It will have two. So maybe not write it this way. I'll write it down. Two real distinct root. Now what do you mean by distinct? They are not same.
Not same, different.
For an example, for example, these are different roots, and roots means nothing but the x-intercepts, right? So that means this d tells me how many x-intercepts it has. Understood? So now if d is greater than 0, it will tell me, okay, there are two x-intercepts. There are two real distinct x-intercepts, right? So now what will be the d value for this particular equation? I mean for this particular graph? What will be the d value?
Greater than 0.
Greater than 0.
Correct. So now this d value should be greater than, definitely it is going to be greater than 0 because it is giving me two real and distinct.
Unequal roots.
Correct. Correct. Now what about this? When d is lesser than 0?
No real roots.
No real roots.
Imaginary.
Okay. Forget about what is that imaginary thing, but for time being, just think there is no real root. So how will the graph look like basically? Basically, it will never touch the x-axis, right? So the graph will be upward like this, or it can be downward like this. It will never touch the x-axis. Look at this. Will this curve touch the x-axis ever? No. What about this? This curve, will it touch the x-axis ever? No. So you will get the graphs like this. Okay. So I think I drew one graph here. So we had this equation here. Look at this, which we took this equation, and when we draw the graph, we found out something like this here, right? So was there any x-intercept for this curve? No. So this is the one where you can think of that d is lesser than 0. Okay. Then what? The other thing is, what about when d is equal
to 0? Same roots.
Real and same root.
Okay. So
one root.
There are two real, but I can say one distinct root. One distinct real root. Okay. So basically, how will the curve look like for that? You will get something like this. It will touch the x-axis, that's it, and it will bounce back. It can be something like this.
What is the meaning of distinct over here?
Oh, not distinct. I'm so sorry. Okay, so it's going to be one
equal root. Equal and real root.
Oh, basically one real root or
equal and real root.
Two
So
equal real roots. So we can say
Two
one
equal roots.
one
One repetitive
multiplicity
root.
of two, right?
Sorry, I didn't get you.
So we can say one real root with multiplicity of 2. We can say that, right?
Exactly, you can say that. Okay, so now over here, could you tell me the right word that we can write here? How are you convinced? Two real
and equal
repetitive root.
Real and equal roots maybe. So basically, how many roots does this have? Only one root. And this has only
In
one root.
question, as the question papers we saw, it says only one real root.
One real root?
That's all, sir. It's only
One real
says no.
repeated root. One real and equal root.
Okay, so
Repeated
however,
equal.
basically, okay, so you just understand it, what I meant to say, it's basically there is only one root. However, you can understand whether it is two real and equal roots or repeated roots or whatever, that is up to you. But I'm just taking up this terminologies like this, okay? Okay, it all means the same. So now if I have to tell you, how will the graph look like? This is what it's going to look like. Now look at this, this curve touches the x-axis at
It will be on the x-axis.
Yeah, and it is touching just at one place, right? Okay, so how will the equations look like for these kind of curves? It will be something like x minus, let's say, a the whole square. Okay, so a can be either positive, negative, or whatever. So, but what is to be noticed here is, if this is my a, let's say if this is my a, look at this. What is the degree? It's 2. Let's say the curve was coming here and it is bouncing back. Okay, so all those who still did not understood what I'm talking here, we'll discuss this in week 4. Fine. So this is more about week 4 graphing, so we can just discuss that. Okay, so I think we are done with all the types of graphings. Okay, so a quick question to all of you. Okay, so now a question is, now I think we are done with all kind of graphings that we can do. So now let me just see how much you understood. Okay. Okay. So it's going to be something like this also. Maybe I can just do it like this. Okay, so now consider this as a parabola. Okay, fine. And okay, so could you tell me what is a value here? A is positive or negative?
Positive.
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 All of you?
Positive.
Positive. Right. So this is a is positive. Yes, this is right. Okay. So what about C value? C is equal to 0. Is this right?
Zero.
Okay, fine. X equals to minus b by 2a, which is nothing but my axis of symmetry. Is this positive or negative?
Negative.
Negative.
Of symmetry. Just a minute. So axis of symmetry is
Negative.
negative. So maybe I can just write down here. Okay. So axis of symmetry is negative. Well, that is fine. 1 minute. Let me ask you a question, then I can take up your question. B is positive. Is this right?
Positive.
Yes, sir. B is positive.
So all of you can tell this. Okay. Vertex will be okay. So vertex.
Third quadrant.
Okay. So maybe I can just say this, not third quadrant and all. Just forget about this. If vertex is something like minus a by.
Sir,
in this
one
form,
second.
is this right?
Sir, 1 second. Sir.
Yes.
A is B is positive because A is positive, right?
Right.
Thank you, sir.
Yeah. Now vertex is going to be in this form. Is this right?
Yes.
No, sir.
Yes.
Is it always true? What if is this always true for this particular for this particular curve? Yes.
So please repeat.
Yes, it is going to be. It is always true. I'm asking you, is this sentence always right for all the values of A? I mean to say for all the values of A, but one thing that you have to notice is A is positive. So this is always going to be positive. That means my axis of symmetry will be negative for sure, right? So this is going to be right. Okay. So now what more we can do with this? Okay. Would you tell me what is discriminant value? Discriminant is greater than 0?
Greater than or equal.
Greater than
equal.
Greater than 0.
Sir, how did you get vertex as minus a, x coordinate of the vertex?
I'm just telling if my x is, let's say, minus a, then is this the thing. Okay, it's like this.
Okay.
Right? I'm not finding out here. Is d greater than or equal to 0, or is this a right statement?
Wrong statement.
D greater than 0.
So d greater than 0 is the right statement, because how many x-intercept does it have?
Two.
So there are 2 x-intercepts. That means 2
Two distinct real roots.
Yeah, two distinct real roots. So therefore, this is also right. So now, just looking by the graph, we can talk so much, right? Now that is something with the graph. Now let's look with the equations. Now what all we can do with the equations.
So I had a question.
Okay, fine. I'll take up your question, then I'll just discuss the other one. Yes, tell me.
In this, there won't be a question like find out the axis of symmetry, right? So what type of questions can come regarding the axis of symmetry?
Okay, you see the question, then you'll understand. I won't be telling you here.
Like how will they formulate it?
How will they formulate it regarding the axis of symmetry and all this? I'm
Yeah,
telling
like
you, see, you will be very easily able to understand what is that they are asking in the examination, okay?
Because in mocks and all, the word problems are pretty tricky and you can't even understand what they're asking.
So we'll check that word problems also, which words are really tricky. We can see that, okay? I don't think so that should be a big problem when you try doing again. Okay, so let's go with this. If I'm taking f of x is equals to, let me take 4x square plus 5, not 5x, let me give some other good number, 8x plus 9. Okay, now a quick question to all of you. Is A positive?
Yes, sir.
Yes, sir.
Yes.
You know this. This is just simply looking at the graph, you can say. So maybe this is not the right question to ask you. Okay, the right question to ask you is what about axis of symmetry is on the left hand side or on the right hand side?
Left hand side, sir.
Left hand side.
Minus.
Okay, so why you are saying left hand side?
Because
Because
B
B
is
and B both are
positive and A is
positive.
also positive.
Both are positive and therefore, so maybe left hand side or right hand side, or maybe I just simply write down left hand side and make it tick over here. So axis of symmetry is on the left hand side of y-axis. So is this right statement? Yes. Okay. So now what about y-intercept? Could you tell me y-intercept is
9.
basically
9.
y-intercept is 9. Is this right? Yes. Okay. Could somebody tell me what is the vertex quickly?
-1,
Minus
5.
one.
Minus 1, comma.
-1, comma 5.
-2.
Minus.
Check this. Check
Minus
this.
1.
Minus
5.
5.
Minus 1, comma
Minus 1, comma 5.
5. Is this right? Yes.
4 or 5?
5. Just substitute here, no? This will become 4 and this will become -8. 9 minus 8 is 1. 4 plus 1, 5. Okay. So now we are done with the vertex. What about discriminant?
No real root.
Less than 0.
Okay, so that is something we'll have to find out. So
Less
maybe
than
write this
0.
Is it less than 0?
Yes, sir.
How do you get this? Minus b square,
Yes.
square minus 4ac. So a,
Yes, sir. The 4AC value is greater than the B square.
yes. Because 9 8 is 72. So therefore it is lesser than 0. Well, this is right. Okay. So now we have x-intercept. So now what about x-intercepts? Okay, so basically there are two x-intercepts. There are two x-intercepts. Is
No
this
real
right?
roots.
Sir, two real roots. There can't be any X-intercept.
Whether this is right or wrong.
Wrong, sir.
Wrong. So there is no doubt you are that confident. Very good.
Sir,
So I
one
think-
second, sir. One doubt.
The one
And
question
it will
is
be.
there.
Hello,
Yes.
sir. By
In the
seeing,
question number 1.
Just a minute. Let's let Radha speak. Yes, Radha.
sir,
please.
by seeing just the equation, how did you come to a conclusion that axis of symmetry is on the left-hand side of the graph?
Okay, because I always have in my mind this thing minus b by 2a. B
Okay,
is
so
positive, A is positive. That means overall this is negative.
negative.
It is
Okay,
negative,
okay,
therefore
okay,
it is going to be
fine.
less.
Okay,
So
sir. Thank
essentially
you.
we are not writing it, but in our mind we are calculating.
Yeah. Okay, fine. Thank you.
Okay.
Understood.
So now I think these are the major things that we can do, right? Now we can just look at the graph and we can do all the things that is needed. We can look at the equation and we can do all that thing which is needed, right? What more you need to do in this quadratic equations, right?
Can you explain one more the last point? Minimum and maximum value.
Okay, I'll come to that part.
Sir, in example 1, the vertex you have taken minus a, we are getting, I am getting confused because the general form is ax square plus bx plus c. So are we taking a that only?
No, that is not okay. So forget about this a term because I think all of you are thinking as a leading coefficient. So let's say if it is
Yes.
minus p, then this has to be minus p. Now it should be
Fine,
fine.
sir. Fine.
Okay.
Thank you, sir.
All right.
Sir,
So
and can you
now
explain the last point? There are two
x-intercepts.
Yeah.
Okay. When do you say there are two x-intercepts? When d is lesser than 0 or greater than 0?
Greater than 0.
Tell me.
Greater than 0.
Okay, so those who know, that is fine, but those who did not tell, the person who is asking me, tell me when there are two x-intercepts, or when there are two real roots, basically two real and distinct real roots. I mean, two real and distinct.
Less than
When
0.
d is lesser, when d is greater than 0, right? Look at this. When d is greater than 0, you will have two real and distinct roots, right?
Okay. Yeah, based on discriminant, we are determining
Correct.
this.
Correct.
Okay,
So
sir.
instead of saying roots, I use the x-intercept.
Okay, sir. Thank you.
Okay.
Sir,
Welcome. Yes.
so may I ask?
Oh yeah, you are still having a doubt. Yes, Saranya, please go ahead.
Sir, question number 1. In question number 1, the second statement, why did you cross the c equal to 0 point?
Oh yeah,
I
right.
think
It should be right.
Yes, sir, it should be true.
Thanks.
That's
because
what I
c is equals to
have to
0.
ask.
Okay, thank you. And this clarified the other doubt also, because there might be someone who might be thinking, whether this is right or wrong. And now I think, is it okay to all of you?
Yes, sir.
Yes, sir. Fine, thanks.
So here C is indicating y-intercept. So here C is indicating y-intercept.
Y-intercept, yes.
Okay.
Right?
Yes, sir. Yes.
Yeah. Okay, fine. So now, those who did not get it, or let's say you partially understood, watch this video again. I think this is the most we can do for this, right? Now let's get to the other part from the main topic, what I had told you. Like, what was that thing? That was reflections, basically. So let me just highlight that part here. So whenever I'm highlighting something, this is all important, just, whatever I'm doing here. So first of all, understand this. Let's say if I'm drawing a quadratic equation, something like this, okay? Not quadratic equation, but so let me say this is my f of x, fine? So now if this is my f of x, and if I have to draw the symmetric of it, basically the symmetric curve of this along the x-axis, what will happen? Okay, maybe not this, but let me take it some other way around. Something like this. Okay, so I'll just mute all. Fine. So now just pay attention here. Now look at this. Call this as f of x, okay? And I'm discussing about what do you call it? Reflection. Okay. So reflection of f of x, basically. Let me say a reflection of f of x is g of x, and I have to draw the curve for this, okay? So now if this is, note this, if this is my axis of symmetry and I say this as 1 comma, say -1, okay? So now how do you draw the axis of symmetry? Okay, so let's see that. How do we do this? Just a minute. Let me use some other pen. I'll use red color here. Okay, so now if I have to draw the reflection for this, how is it going to be? And along what? So the next question should be, okay, reflection along what? So along x-axis, that is my thing. So if this is my x-axis, okay, and this is my y-axis. So now I'm telling you, okay, what is the reflection of f of x? It's basically rg of x. Then how will that curve look like? Okay, so this point basically will be somewhere here. So if this is 1, and if x-axis is my reflection point, then x coordinate will not change. Only the y coordinate will change. That is something we have to understand. Okay, so now if I have to take this, the x coordinate will not change. That is, it's going to be somewhere here. Okay, so and the roots will be same. This x-intercepts are going to be same, and if I have to draw this, it's all that I have to make sure that this is going this way, just the opposite, and this touches this point like this, and it crosses like this. Okay, so this is my g of x. So what did we notice here? We have to notice two things. Okay, just a minute. I think. Okay, so now we have to notice two things here. So first of all, when I take the reflection of any function, any quadratic function, the x-intercept does not changes, right? So this is one thing to note.
Sorry, sir. So are you talking about reflection as a mirror image?
Yes, yes, yes. Mirror image along the x-axis.
Okay.
Okay. So the x-intercept does not change. Right? What else are not changing? Basically, this is about x-intercepts. Basically, the x coordinates as a whole does not change. X coordinate does not change. Essentially, this is the major thing to say, and this is like subset of it to say, this x-intercept, right? But just to highlight that, that is why I have written that x-intercept does not change. Basically, x coordinates itself does not change. Look at this x coordinate. Could you tell me what is this vertex? It's going to be 1 comma.
So it's still 1 comma and y something. 1 comma 1, sorry.
Something. It's going to be something basically. And what about the y coordinates? Y coordinates, the sign of y coordinate changes. The sign of.
Excuse me, sir.
Just a minute. Just a minute. The sign of y coordinate changes. Now these are the three things that you have to make a note of it. Now look at this, x coordinate does not changes, but the sign of y coordinate got changed, right? Over here, what is the point at this place? Let's say some values, right? The y value is what? 0, which is eventually not making any effect of it, right? So this is going to be the same. Look at this place. If I have to just draw any point over here, so if I say this point, if this is, let me say this as 3, 5, right? Then what about this?
Minus 5.
So why? Because the x coordinate does not changes, but only the sign of the y coordinate changes, right?
It's following sometimes of symmetry, I think.
Yeah, it is symmetric. Yes, it is symmetric along the x-axis. That's
I think it will be -3 5.
Why -3? Look at this.
This
is x value.
X is the same.
Right? So this is about the reflection of a particular function which is given. Okay. So what is that thing that you have to understand? So I'll just mute all and just tell you what is that I'm trying to emphasize here. Okay. So now pay attention to what I'm saying. First of all, if I'm drawing a reflection of any function in the sense a quadratic function along the x-axis, basically my x-axis is the mirror. So what are we doing here is reflection of f of x along x-axis, right? So if that is something we are doing, the x-intercept does not changes. X-intercepts remain the same. So x-intercepts are this. You see, the x-intercepts of the mirror image of this function f of x does not changes. The x coordinate as a whole does not changes. That is something we have to note down. And the sign of y coordinate changes. Clear? All of you clear with this?
Yes.
Assuming it is clear. What is the other doubt somebody?
Sir, your pointer can be a little large because sometimes we don't see where you are pointing actually.
I'm sorry, Raj. What is that?
Sir, this is he's saying, can you please just zoom in because the font is kind of
your
small.
pointer, right? Mouse pointer. I mean, pen you are using.
Okay,
That
okay,
pointer
fine.
is very. Yeah, sometimes we don't know where actually we have to look.
Okay, I see. Maybe I'll just use more thicker pen here. This is thick, but I have zoomed my screen so much that it is more thinner now. But it's fine. I think we'll go to the next page now. So it's done. So
Sir, what kind of questions we'll get as far as this reflection is concerned, sir?
okay, so as far as this reflection is concerned, okay.
Any example?
Any example, I would say, okay, if my x-intercept of f of x is so and so, sorry, if x-intercept of f of x is so and so, or I can just ask you a question, the x-intercept, if the roots of, or maybe if I have to just ask you some MSQ questions, okay? So I'll just simply ask you, okay, the roots of, are you guys able to hear some background?
No, sir.
Nothing?
No, sir, it's clean.
No, it's clean. Okay. The roots of f of x and minus f of x are same. Is this right?
Yes, sir.
Yes,
sir.
Yes,
Yes,
sir. This is right. Because you notice this f of x, if this is my f of x, what is my g of x? G of x is definitely minus f of x. Clear with this?
Yes.
Yes.
Okay. So this is
Yes,
a
sir.
kind of question that can be asked, because
Okay.
this minus f of x indicates what? Reflection of f of x. That's it, along the x-axis.
Okay.
Vicky, what is the G? I mean, is there any meaning for G?
No,
It's
it's
just a
not a
name of the
meaning, but
function.
it's just I'm calling it as a G. Okay.
Okay.
So now quickly, now look at this
So,
particular
sir,
function.
always reflection is minus of the minus f of x, right?
Exactly. Whichever is the function, it's just the negative of it.
Yeah. Okay. Okay.
Okay, clear?
Thank you. Yeah.
Sir, can we find the area of this fx and gx? Can we find the area?
You
This
can
area.
do this, but currently let's not do that. Okay.
Okay, so, but we can
What
do
kind
that,
of
right?
area we can?
Basically,
using
this area.
calculus.
This is what he meant to say. Can we find the area for this?
I think there is an integration we call.
Yes, sir.
Yes.
So
Yeah.
that is something we can do afterwards.
Part of calculus.
Now.
Okay, sir.
Okay. I don't know why is this not increasing size. Okay. Okay, fine. So this is bit thicker now. All right. So now just quickly, let's quickly come with something called one-to-one function and one-one function over here, and that will be the end for this, and then we can jump to the week 4. Okay. So now look at this particular function. Okay. Okay. So consider this as some function f of x, and it is a quadratic function. And whenever we define a function like this, a function is from, let's say, quadratic functions are generally defined like this. Okay. So what does this represent?
Domain.
The domain and range.
This is not range. This is called
Codomain.
So essentially, what are we doing? Recall in your first week, what do we used to do? We used to map set A with set B with some relation, some mapping f, right? So now what over here also, this function is a mapping from one set to another set. Here, what is my first set? R. What is my second set? R. Right? So this is mapping from R to R. So if I consider this function f of x from R to R, then what do you notice from here? You basically notice what this function is mapped from R to R. So this is basically your domain set, right? This is what we used to say, right? This is our domain set, and this is called as what? Codomain set.
Codomain set.
Okay, so now all of you are clear. So codomain set tells you what? Basically, whatever you give now, if I have to tell you this is my function f, the domain set are the input. Basically, this domain set is the input for this machine, and the output thing, whatever it comes out, is the output thing, whatever it comes out is called as range. So whatever this output is coming, where does that falls? It falls under this codomain set.
Codomain.
It is inside the codomain. That means what I'm trying to say here is whatever this machine is giving me output, this function machine is giving me output, the output must lie in this codomain. So you are understanding? It must lie in the codomain. I'm not claiming that it should be equal to codomain.
It's a subset of codomain.
Exactly. It is a subset of codomain. So whatever the output, so this output is called as a range, and this range is basically a subset of codomain. It can be equal. That is also okay. It can be equal, but definitely it has to be within this codomain set. Okay. So now this function f of x is defined like this. Okay. Now this is my y-axis. This is my x-axis. Right. So whenever I'm saying this x-axis, just a minute. So what do you really mean by this? Okay. So this x-axis indicates your domain set. Okay. So over here, since I'm telling R, that is why it represents domain set. If I restrict it, it is no more, right? So understand, but it is definitely on X. And whatever the output you get, where do you get that output? On Y, right? So now if I have to tell you, okay, not that way, but look at this particular function. Look at this particular curve, okay? Could you tell me if this is one-to-one? Does this represent one-to-one function?
No, sir.
No, sir.
No, sir.
Okay. Anybody who is getting confused with this?
No, sir.
Okay. So what do you mean by one-to-one function? So basically in one-to-one function, you have to make sure that there is, can somebody tell me what you mean?
So for distinct input, we are going to get distinct output.
It's a bijective function. Injective.
Let's say if I have these 4 points and over
Sir,
here I have
I have a doubt.
So I think the every quadratic equation is not one-to-one.
Exactly. We'll come to that part, but just a minute. So basically, what do you mean by one-to-one? For a single element in a domain set, right? It must not
Is
have.
the
Okay,
next
so
to
yes, please. What is that?
For every value of x in the domain set, it will have an image or an output in the range.
It will have a unique image basically.
Unique,
The
yeah.
horizontal line test.
We'll come to that part also. So you first notice this. You cannot have something like this because for it to be a one-to-one function, what you have to make sure is that every element in your domain set has got a unique image in your codomain set. Now look at this. One has got an image called A and 2 has also got image A. So this is not a unique image, right?
Yeah.
Right? So this cannot happen.
one function.
Right? So that means, look at this part. For an example, if I have to just simply draw a horizontal line over here, right? If I have to simply draw an horizontal line like this, okay? And notice this, there are two x values. If this is my x1 and this is my x2, and if I put it here, if this is my x1 and this is my x2, what is the output that I'm getting? Let's say this is 5. This value is 5. So don't you think they both are merged here? Like this? Right?
Yes, sir.
Yes.
Right?
Yes, sir.
Therefore, I can say this is not one-to-one function.
Yes, sir.
Right?
Yes.
Okay. So
Yeah.
for now, if given a graph, okay, given a graph, how do you really find out whether it is one-to-one function? What you have to do is just draw a horizontal line. Okay. And if that horizontal line, I mean, you cannot simply draw a horizontal line here and then tell me, okay, it does not touch this. You cannot tell me that. You shouldn't be that because you are trying to prove something. You shouldn't be like, I'm not proving this, right? Because generally students ask questions like this. So I'm trying to say that. Okay. So now understand this. I hope this is clear with this arrow diagram, which I have explained it here. So whenever a curve is given to you, all you have to do is just draw a straight line touching that curve. Maybe you can draw multiple places wherever you want, but it should touch that curve, or it may, I mean, it may or may not touch the curve, but whichever, if basically a curve is given and when you draw a horizontal line, if it touches that curve at just one place, then it passes it passes the horizontal line test. So basically this is called as horizontal line test, which you will study in week 5. But just I don't want to give you more since it is week 5 content, so don't worry about it. This is important in this aspect. All I have to do is just draw a horizontal line, and all I have to do is just make sure that it touches at one place. If it touches at one place, then it passed the horizontal line test, and then you say that yes, this is one-to-one function. And if it is touching at multiple places, like look at this, it is touching at 2 different places. In this case, it will fail the horizontal line test, and this is no more one-to-one function. Okay, clear with this?
Yes, sir.
All you have to do is
Yes,
just
sir.
draw a horizontal line and make sure it
Sir,
is
can
touching
you
the curve at one place. Okay.
That means if the horizontal line touches at one point, then it is one-to-one.
It is going to be one-to-one, but for this
Sir,
case,
can you show the example for this?
okay, I'll give you some counter examples also.
Sir,
Then I'm quickly
I
moving to
have a
week
doubt.
5 because we have to.
Sir,
Just a minute.
Sir,
Just a minute. Let me clear this doubt first. Maybe this horizontal thing. Now look at this curve, okay? Now let me say I have a curve something like this. Now draw any horizontal line. How many places it's cutting this curve?
Only one in each place.
Only one place.
Only one place. That means it basically passes the horizontal line test. If it is touches this curve at most, I mean at one place only, then only it passes the horizontal line test. Okay?
Sir, your voice is disturbing.
Sir, your mic.
Your voice is not clear.
Your voice
Now is
is
it
not
fine?
clear.
Now.
No,
No.
sir.
It's slow.
So, that
It
mic
is
is
too
fluctuating.
Now is it fine?
It's too low.
Very low.
sir.
Too low.
So now you're not audible at all.
Is it audible now?
It's very
Just too low.
It's still low.
Yeah.
Is
Yeah,
it
now
okay?
it's audible. I
Now
think
it's
you should
audible.
Audible?
increase your volume.
Yes.
Yes,
Yes,
sir.
audible.
Okay, fine. So now what I meant to say is, if this is my, let's say this is x-axis, this is y-axis, and this is my curve, and I can draw any number of horizontal line, and whichever horizontal line I draw, it must touch the curve at only one place. If it touches at only one place, then I say that this passes the horizontal line test and it is one-to-one function. Or forget about it passes the horizontal line test and all that thing. If it touches the curve at only one place, then it is one-to-one function. Okay. Now look at this curve. You draw any horizontal line. How many places it is touching? Two places. Therefore, this is not a one-to-one function. Now you can come and tell me, okay, fine. If I draw a horizontal line here, but the question is, why will you draw that, and why will you try to prove that this is?
Can we define a function one-to-one in some like particular domain? Like the function is one-to-one from -infinity to x2.
Come again?
Like the function is
Take this.
one
F
to
of x is equals to x. Okay. How will the graph look like?
straight line passing through origin.
Now you draw any horizontal line here. At how many places it touches the curve? At one place only. Since it touches at one place, therefore it is one-to-one function.
Sir, for quadratic, if domain is not R,
Correct. I was coming to this.
Then it, okay.
So let's say my x belongs to, let's say 0 to infinity.
Yeah.
Now, if that is the case, then how will my curve look like? So I'll just simply draw that. So at that point of time, okay, just how will the curve look like? Just like this, right? This green color thing. This is what the curve will be look, right? So if this is my curve, and if I draw a horizontal line, at how many places is it touching the curve?
One place.
And therefore at that point it becomes
one-to-one.
Okay. So now is it clear?
What about a parabola that is symmetric on the y-axis? With axis of symmetry on y?
Same thing, no? Just draw this. Maybe you
No,
just draw a curve like this. Now tell me, does it assist
No,
the
with the
horizontal line?
axis of symmetry on y.
Axis of symmetry is on the y.
Sorry, on x. On x.
Okay, so that is not a function at all. And we are not dealing with that, so just forget about it.
Sir, the previous, the 0 to infinity, if we say 0 to minus infinity, it is not one-to-one, right?
No, it is still one-to-one. Okay, yeah, I think yes. What you are telling is right. Now let's say I draw a parabola and this is something like 0 to infinity, something like this. Let's say this is what? Now let's say this is my parabola, it was going something like this, but I'm restricting its domain, something I'm saying that 0 to infinity. Does this represent one-to-one function? You would say, okay, here it touches one, here it touches the one, but we have to find out where it touches at more than one, right? So just look at this place. It fails the horizontal line test.
The inverse function of this parabola, is it one-to-one
Does
function?
not exist. Does not exist. For any function, for any function, for any function to for its inverse to exist, it must be an one-to-one function. Since this is not one-to-one function, the inverse does not exist.
Okay.
Right.
Okay. So now let's go to the next part. This is all from here.
Can you repeat this line again?
Okay, so that you will learn in week 5.
So how can we determine that function is onto by graphically?
Onto by graphically. Okay, just look at this function. Okay, so since you asked this, so maybe I'll just do this and then I'm quickly moving to the next part. Okay. So this is the last question that I'm entertaining here and we are done with week 3. So now look at this. Now let's say this is my function f of x and let's say my function is defined from r to r. Okay, and let me say this is 5, 10. Okay, does this look at this function f of x? Is this one-to-one?
No.
Is it one-to-one?
No.
No. Is this onto?
No. It's not
No.
on.
No.
Okay. What is the definition for onto?
The range should be equal to codomain.
Should be equals to codomain.
Range is
Okay.
equal to
Now look at
codomain.
this. What is codomain value?
R.
R.
Why?
Okay, so this is not this
R,
R, but
all
this is
real.
the range. So maybe I can just write down range. That will be better. Range is equals to codomain. Could you tell me what is the range for this function?
Minus infinity to 5.
Minus
10
sorry,
to
Minus
10.
infinity to
Minus
10.
infinity.
Minus infinity to 10. And 10 is included. Right? So now look at this. This is my range. Now if I have to, what is this codomain? Codomain is R. So I'll just simply say this is my
Real number.
codomain. Right? So this is my real number. But what is my range? Range
10,
plus
sir. Minus infinity to 10.
just up to 10. If this is my 10, this is my 10. Only these values is my range. Right? But what about these values?
They are not
These are not
covered.
common. That means range is not equals to codomain.
then this function is
Means
not on.
range is not equals to codomain, therefore this is not on. Clear?
Yes, sir.
Okay, so I'm not going to repeat this anymore, and I request for you to go watch this again, and so that you can understand. I think we have elaborated this a
Is
lot.
subset of
And
all
sir,
codomain, right?
won't we discuss FOIL method?
No, we will not.
Which
That is
method?
that is not important.
Not exactly at this point of time. Yes.
Okay, sir.
It is simply multiplication, I think.
सर
Yes.
एक फंक्शन की जो मैक्सिमम और मिनिमम वैल्यू होती है वो थोड़ी बता दीजिए.
Okay. So I just told in the very beginning that for quadratic function, if it opens upward or a downward, could you tell me what is the maximum value for this quadratic function?
सर यही 5 and 10.
10.
Not 5 comma 10. I'm asking value. Value is 10.
10.
Right? Okay. What is the
Yes, sir.
minimum value for this function?
Minus
sir,
infinity.
minus infinity.
Minus infinity.
Because
Does
minus
not
infinity is, it's basically not existing number, right? It's basically anything.
Yes, sir.
So for this particular curve, if parabola is opening downward, the maximum value exists, but the minimum value does not exist. Now is it clear?
Yes, sir.
Okay.
सर
Now if the
लीनियर फंक्शन आ जाए तो
अगर linear function है तो फिर if it is a linear function means a straight line, right?
Yeah.
You don't have a maximum value or a minimum value for this.
Minus infinity and infinity.
Yeah. Until or unless you restrict the domain, you cannot claim that. Okay.
Yes, sir. जैसे सर एक एग्जांपल है 5 mod x plus 20 minimum value.
5
mod x 20 plus 20.
Plus 20. What is the minimum value? Okay. So now look at
Yes,
this
sir.
particular thing. Mod x means how will the graph?
Your voice is not
Sir,
audible.
your mic, sir.
Now is it better?
Yeah.
Yes, sir.
Yeah. Yes. It's
Okay.
better.
So okay. So now look at this. Whenever you want to determine what is a maximum value or a minimum value, mod x function, how does it look like?
20.
So plus and minus.
Always give positive.
It's always
Positive
absolute
So
value.
what is the minimum value this function can give you?
0.
0.
25.
20.
Okay.
Zero.
Since he highlighted this is really important. Just pay attention to this. Okay. This is like week 1 concept. So mod x, what is the minimum value? You know that the graph look like this, right?
0.
Yes, sir.
V
Right?
shape.
So what is the minimum value? So this is another function. This is mod x function. So what is the minimum value for this function? Could you tell me?
0.
0, right? So you told me 5 mod x plus 20 something, right? So when will this be minimum? When mod x is 0, right? So when mod x is 0, that means what is the minimum value that you are getting?
20.
0 plus 20 is 20. Okay. So now very interestingly you told, okay, now you understood, right? What is the minimum value for this? Your doubt is clear?
Yes, sir.
Okay.
Yes.
So now I have another question to all of you. If this is mod x plus this is mod y, is this equal to 1? Okay. What does this represent? This is very important, okay? What does this represent? Could you tell me what are the, basically could you tell me what are the set of x values and what are the set of y?
0 to infinity.
Could you tell me?
Minus 1.
0 to infinity, I think.
I think minus 1, 0, 1.
0, 1.
Minus 1, 0, 1.
Real number, sir.
0 and 1, sir.
0 and minus 1.
It becomes very clear when I'm doing this?
Minus infinite.
Let's say this is 1.
How is it a circle?
How is it a circle? I mean, just trying to do this, but it's not a circle, but I'm just asking you, does this represents?
Right. Maximum 1, minimum.
When, just think, when x is 0, what is the y value you get?
1.
Plus or minus 1?
Plus minus 1.
Minus 1.
Right? When y is 0, what is the x value you get?
Plus 1.
Plus or minus 1.
Minus 1.
Right?
Plus minus 1 right now.
Okay. So that means, what is the domain for this?
Domain is
Domain for this?
Minus 1 to 1.
What is the domain for this?
Minus 1 to 1.
Minus 1 to 1.
Minus 1.
Minus 1 to 1. And what is codomain for this?
Minus 1 to
Sorry,
1.
not codomain. What is range for this?
Range is minus 1 to 1.
Minus 1 to 1.
So interesting, right?
right.
Yes, sir.
Yes,
Right?
sir.
So that means it can only take x values between this, and it will give you output values between this. Right?
Yes, sir.
Right?
Right.
Yes,
So
sir.
this is one interesting thing that you have to know. All right?
Sir, here codomain is all real numbers.
That is up to me how I want to give. I can say if my function is defined, of course. Here I would define my function domain saying that minus 1 to 1, and my codomain is R. So
Sir,
is this onto?
Sir, how is it graph looks like?
Could you tell me how will the graph look like? The first when I draw, you guys, scared me saying that how did you draw a circle? But just think, can this be a circle?
Yeah, this can be a circle. Now what?
You take any point. You take any point like this. Take any point. Let's say this, if this is 0.5, what will be the other thing be? 0.5.
0.5.
Right? You take any point. It will turn out to be circle only.
It could be. Yeah, it could be.
All right. So fine. Let's go to the next part. Week 4. And I think we did a lot of discussion here. And then we have to delay it by half an hour. So it will
Sir,
go
will
to
these
10.
notes be available?
So will you revise SSE also?
SSE. Oh yeah. Since you asked this SSE, yes. Since I mentioned that.
SSE is sir very confusing.
Okay, so I'm not going to tell you anything more on SSE, but just since I have mentioned here in the very beginning that yes, SSE, so I'll just ask you one question over here, okay? That is something important.
We will get notes.
You want this notes?
Yes, sir.
Yes, sir.
Fine, so I'll provide you this. Okay?
Thank you, sir.
Okay, so one
Thank
more
you.
question, one quick question. So I'll just, okay, so let that be as it is. Okay, so now just understand this. Okay, fine. So if I say, if SSE, now consider this as question 2 and this as question 1, okay? If SSE is represented by, let's say SSE is f of x is equals to 5x square plus 4x plus 5, okay? Then what is the
5x square or x?
minimum SSE value? Could you tell me?
Minus
-2.
Go ahead.
-2.
Is that Vertex?
Yes, sir. Yes, sir. At Vertex.
So what is the value I'm asking? What is the
Oh,
value?
value. Okay.
Minus 2, so it will be like minus 8 plus 5.
1.
Value is 1.
1.
1.
9 minus 8.
So first of all, let's understand this. First of all, this is parabola opening upward, right?
Yes,
The
sir.
minimum value will be somewhere here. And if this is representing SSE, so definitely the minimum value, that is something I have to take, right? So it is not always X. What am I asking you? What is the minimum SSE value? I'm asking you the value, right? So first of all, let me find out what is this minus b by 2a. So what is this minus 4 by
Minus 2.
which is nothing but minus 2. And if I substitute this into this, that will give me my SSE value, because this entire thing is representing my SSE value, right? So if I just simply substitute over here, what do I get? Minus 8 plus 5, which will make it what? 1. Right? So what is the SSE value for this quadratic function?
1.
Sorry, that is the wrong thing that I asked. What if this quadratic function represents SSE, then what is the minimum value of this SSE? 1. Okay, so this is one interesting way of asking questions. So you also have some of the questions which we have done it, and I think you also have some questions on week 2, week 3, which involves SSC. So this is one hint that I can tell you, that since I have written SSC in week 3, that means it has got some importance in week 3. Okay.
Okay, so
Sir,
if we
please
are
ask me
using
one
a
question.
quadratic
Sir,
function to
Right.
like
there
So
is
you can
a formula for SSC. Can you just repeat that?
you just want to know the formula?
Yes, sir. That root of yi minus f of x.
Yeah.
So if I tell you all that thing, I'm not going to finish week 4. What do you want? Tell me.
sir, they can cover that till
SSC can be covered because there is
So
so
if
many
you could
videos.
tell this at the end of the session for
right at the
completing
end
that.
of the
Because
So
see,
please
week
cover week
4
4 as it's important.
exactly.
And
So the way we
SSC
let's go it in that.
formula is
Okay, let me talk
provided.
now. All of you, let me talk now. Okay, so I think I covered week 3 completely and I have entertained questions there. Week SSC is like week 2 concepts. Let's not do it here. Okay, now let's go with our flow. You can freshen your mind and we are going to week 4. Okay, so all of you clear with this?
Sir, can you just tell the formula, sir? Only the formula.
Y minus f of x whole
Y minus
Y
pi
bar
cap.
You are not able to solve the questions using this.
But
Like if
what will
you
you get
don't
if I just write
understand
down the
this.
formula? I don't get it.
Like it is different for every function.
Okay, so if it is like this, then you can write down actual value
So it's in video.
minus predicted value. There is so many things we have done.
Yeah.
We can say that y minus
whole
function
square.
whole square.
Summation I equals 1 to n actual value of I, predicted value of I. Okay, so now you will tell me, explain me these terms. So this will become again another 15 minutes thing. Okay, so I request all of you to just see this. This is extensively done. Okay, so if I do that thing, it is another discussion altogether. Okay, so do not mind this, but we don't have time, and this is something we cannot do it right away. Okay, because there are so many people who are actually waiting for this week 4 to be completed, right? And once this is done, officially we are done with week 4, and then we can say that okay, fine, we are done with this. We can entertain some other questions. Okay, if we have more time. Okay, so now let's go with this week 4. Okay, so now before going to week 4, I want all of you to recall some of the graphs. Okay, so there are certain things that we should know. First of all, we should know what is degree. Degree of f of x. Let's say f of x is a polynomial, since we are talking about polynomial. Okay, before going to this part, if I say if f of x is of 5x to the power of 10 and 0x to the power of 11 plus x to the power of 4 plus x to the power of 10. What is the degree of this polynomial?
10.
10.
So all of you understand, right?
Sir,
Sir.
things
Why
like
is it not 11?
Highest coefficient.
Why is it not 11?
No, it is
default
zero.
coefficient is 0.
Coefficient is zero.
That's it. That's it.
Zero.
No, nothing more. Nothing more. I just wanted to see if you guys are fine here. Okay.
Questions like this is asked like, is this a polynomial or not?
Is this a no, that is like activity question, right?
Right.
Not ask you that. Right. So we'll not ask you this, but you might ask. You might have a question. Okay, is this a polynomial of this much degree or something? That is the easiest thing we can ask. Okay. Okay, so now let's go into week 4. And before going to week 4, I just want some of the things that should be like prerequisite with us. Okay, so I can just say this is prerequisite, and those prerequisite I'm telling you here. So it shouldn't be like you should know this. Even if you don't know this, this is fine. So what is some certain prerequisite? Okay, so what is the degree of a polynomial? Degree of a polynomial. So all of you can tell this, right? So I just want you to tell me whether it is even or odd, and that will suffice the need. Okay.
Okay.
Okay. And leading coefficient, you will have to tell me whether it is positive or negative. That will suffice the need. Okay. So whether it is positive or negative, that is something you will have to tell me. That's it. I don't want anything else from that. Okay. So whether it is positive or negative, then what are the roots? That is something, if I give you equation, you can tell me what are the roots, right? You can just tell me, okay, these are certain roots, blah, blah, blah. Okay. Then what is multiplicities? Multiplicities are nothing but multiplicities are nothing but whatever the power. For an example, if I have to say x minus 2 the whole to the power of 10, then the question will be, what is the multiplicity of 2?
10.
10. So that means, in other words, this 2 is been repeated 10 times.
But
right?
the root is only
Bounce off,
one.
I think.
Right?
The root is only one,
Yes,
right?
sir.
2.
Yeah, only one root, but it is repeated twice. For an example, all of us were discussing what is the multiplicity of this. Okay, maybe not 2 because that will confuse you. So what is the multiplicity of 1? 2.
Two, sir.
If you find the discriminant for this, it will be 0. Okay, so
Yes, sir.
I don't know how far you can think of that way. If you can, that is very good. So now these are the certain things that we have to understand. Okay, now before there is something more. So this 3, 4, and one more thing is 5 and 6 thing is something I will write down here, and then I can just take. Okay, so now certain graphs, like what is the graph of x square? How is the graph of x square?
Passing
Parabola.
through or parabola.
Like this.
Upward
Okay. What is the
parabola.
graph of minus x square?
Downward
Downward
parabola.
Parabola.
Upward
Like this.
parabola.
Okay, so all of you can answer these things. Well, very good. What about the graph of x cube?
They're crossing
Sir,
x-axis.
Crossing the
yes, sir.
x-axis with the origin.
Crossing the x-axis, something like this.
Origin to
From right to left.
And what is the graph for minus x cube?
Left to
Mirror
right.
image.
Left to
Left to right.
Well,
crossing
when you say
x-axis.
mirror image, then you
Second and
must
third
also
quadrant.
specify along what axis, right? So now understand this. So these are certain things that is a prerequisite. Okay, so this prerequisite is something I covered here. So now you can see this all together here. First of all, what is the degree of polynomial? You have to tell me whether it is even or odd. Okay.
Yes.
What is the leading coefficient? Whether it is positive or negative. What is the root? Well, we can figure out what are the roots. We will give you roots. What is the multiplicity? Multiplicity is how many times that root has been repeated. Then the graph of x square is something like this. Minus x square is parabola opening downward. X cube is something looking like this. And minus x cube is something looking like this. So this much is the prerequisite, what is needed, and we have done. Okay, whatever was the prerequisite. So all of you clear till now?
Yes.
Yes, sir.
Yes,
Now
sir.
I will build up here more. So now be with me. These are some important concepts that you should know that. Okay, so if I type something, yeah, fine. I'll just take it up there. All right. Fine. So let me just do it here and then explain you. Now, having known those prerequisites, now look at these graphs. Now consider a function. Now, if I give a function f of x is equals to minus x minus 2 the whole square, x minus 4 the to the power of 3, x minus 5 to the power of, let me say, let it be like as it is, x plus 4 the whole square. Okay, so now this is my quadratic function. This is my polynomial given. Okay, how do you draw the graph for this? Okay, so first of all, steps. Step number 1. What is the degree of this polynomial?
Locate the root.
8.
So 2 plus 3.
8.
Essentially, the degree of the polynomial is the sum of all the multiplicities, right?
Yes, sir.
Okay, so what is so sum of all the multiplicities? So it's basically 2 plus 3 makes it 5 plus 1, 6 plus 2, 8. So this is 8. Is this even or odd?
Even.
Even.
Understand this.
It will bounce off.
Okay, yeah, good. We'll come to that part. But what about step 2? Now, step 2 was finding what?
Leading coefficient.
Leading coefficient. So what about leading coefficient?
Minus negative.
It's less than 0. So negative.
Negative.
Leading coefficient is positive or negative?
Negative.
Negative.
Okay. Step number 3. What are the roots for this? What are the roots you get?
4, 5 and minus
4,
4.
5,
4,
minus
5 and minus 4.
Minus 4. These are the roots.
4, 5, minus 4.
Good. I think we have written it here. Now understand this. Before going further, I want all of you to understand certain things here. Okay. Now look at certain things such as graph of x square. Okay. So we know this graph of x square is something like this. Okay.
Yes,
Look at the graph of x to the power of 10. The x to the power of 10 graph will be again same way, but it will be
More wider.
Yeah, it will be more wider and it goes something like this, right? Likewise, if I have to tell you, okay, what is the graph of x to the power of 100? Again, it is going to be very sharp and it goes like this, right? Now,
Wider or sharper?
Sharper. It's going to be very, very sharp. Okay.
Steeper.
Basically, yeah, steeper is the right word to use. So fine. So now you see this, and if I tell, okay, 0.001 x square, so how will this graph look like? Something like this, more very, very flat, and it goes like this. So one thing that we have to notice is, what is this degrees? Even or odd?
Even.
And if it is even, then what do you see? The endings. The endings are on the same side?
Right.
Yeah.
Right?
Yes, sir.
That is one thing that we have to note from here. If it is an even, then the endings of these graphs are on the same side, right? And if I just simply have to tell minus x square, so it is going to be something like this. The other thing is
Depends
something
on
like
the
this.
leading coefficient.
Again, what is the thing? Again, the degree is what? Even, right? And the endings are on the same side, right? So now one thing that we can tell from here is, if it is an even degree, the endings are always on the same side. Can we conclude that?
Yes.
Yes. Yes.
Okay, so I'll take up doubt at the end, not now. In between, I will not entertain any doubt. Okay, so if it is an even degree, then the endings of the graphs are on the same side. This is one input that you can take. Okay, now look at this curve. This was x cube graph that we drew. How are the endings? Opposite
side.
Opposite side.
Opposite side. The endings are on the opposite side. Okay, so this is the graph of x cube. Now, no matter what you draw the graph of x to the power of 1001, let's say, the graph nature is going to be something like this itself. It's going to be very steep, and it's going to be something like this. But again, the characteristics of the curve remains the same. Right? All of you clear with this? This is the graph of x to the power of. So what is that we have to notice? If it is an odd degree, the endings are on the opposite side. Okay. And this leading coefficient, since this was positive, that is how it was going like that. But what if it was negative? The negative would be something like this, right?
Left side. Yeah.
Like this. Right? And if it is like this negative, then this is going to be very steep like this, and then like this, and then like this, right? So clear with this? So the leading coefficient is determining whether the parabola was upward or downward, or if I'm using a cubic polynomial, whether it is going to be like this or like this, right? So clear with this? These are the two things that is being determined here. Okay. So now look at this part. Now I'm drawing. Just a minute. I'll not take doubt right now. I'll take at the end. Now I'm trying to draw the graph for this. Okay. So now I'll just simply take the x-axis, and I'll take the doubts at the end, means when I'll discuss two examples. Okay. So now, what is the degree of this polynomial? Even. That means endings will be on the same side. This will tell you what? Endings will be on the
Same side.
Endings will be on the same side. And this is negative. That means parabola, something opening downwards, right? So that means this is going to be something like this, right? Right? The endings are on the same side. Parabola. But over before, what I was telling you, when I was telling you x square, the parabola was something like this, right? Why? Because there was only one root, isn't it? Basically one root. But over here, something has been happening.
4 times it.
Something has been happening because of these factors, because of these roots and its multiplicities. Okay. So of course, the nature remains the same, but something is happening in between that is happening because of these roots. Okay. And that is something we will identify here. How is that happening? Okay. So the next step is, first of all, I understood that, okay, the endings are on the same side. Well, that is indicated here. And it is either upward or downward. That is, with this negative coefficient, we understood it is downward. Okay, well, that's fine. Now what? We will just have to highlight these roots, whatever it is. Okay. So wherever this touches, whichever is the least root value, which is the least root value?
-4.
I can just indicate here. What is the most
5.
root value that you are getting? 5. Okay. So what are the other roots? So I can just indicate this is like 4.
2 and 4.
2, 4, 5. 2. So maybe let's say this is my 2 and this is, let's say, 4. Okay. So now let's understand what is happening here. Look at this. At 4, so where is this? -4 means what? Its factor will be what? X plus 4, right? Which is here. What is the multiplicity for this?
2.
2. So what is happening here is, basically this curve goes to this part, and just because its multiplicity is even, right? Because its multiplicity is even, therefore it will not cross this curve, it will bounce back. So it will touch the curve and it will bounce back. And I'm least bothered how much it is bouncing back. I'm least bothered about this. I'm not thinking at all about this, and you should also not think about that, because that is something we cannot determine. Okay, now what at this root? That means basically we are talking about this factor. So at this root, what will happen? So basically this term, because we know that polynomial is a smooth curve, so it will go smoothly, right? So now what? It will again try to approach at 2. But what is multiplicity at 2?
2.
Even.
What it will do? It will try to curve. It will try
It
to
will again bounce.
but it will
Long
again
cross
bounce.
bouncing.
Again bounce.
Right? Okay. Now what is happening at 4? What is this?
It'll cross the line.
It's gonna cross.
So it will go here. But again, you remember cubic, it was there was a slight bend, right? So it will go
Yes, sir.
there with a slight bending, right? And it will
Yeah.
cross this. It will not bounce back. Why? Because this is multiplicity is
Odd.
And now this will again come back. What is multiplicity at 5?
Sorry,
It must
1.
cross in what? It must cross in a linear fashion. No bending, nothing. So it will go like this. So this is what the graph for this particular function is. Okay, so clear?
Okay, sir.
Clear till now?
Yes, sir.
Yes, sir.
Yes.
I know
So the
some
graph
of
is
you might
even
have
or
doubt.
odd?
I am not taking those doubts. Just a minute, wait.
Okay, sir.
Okay, let me give you another example here. Okay.
काहे को तू क्या डाउट पूछता है भाई?
I'll just mute all. Okay, so now just be with me for some more time. I know what your doubts are. Okay, all that doubts will be cleared, so don't worry about this. I have
Sir,
discussed 4-5
Sir, sir, your mic again, sir.
Okay, fine. Okay, so now let's discuss another question. I think it should be fine now. My mic, is it okay?
Yes, yes, sir. Yes, sir. It's fine, it's fine.
Now let us consider another function, and this function f of x is, again I'll give you some minus here. Okay, so minus 1 by 100 x square minus x minus 5. Okay, minus x minus 1 the whole square minus x plus 4 the whole square. Then let me give it as not whole square. Let me give it as 10. That will be better. So let me give it here as something like x. Okay, minus x plus 5 the whole cube. Okay, now again, what is my step number 1? Before going further, how, look at the previous one, look at the previous function, how we had it. We had this x being positive always, right? In these factors, we always made sure that x was positive. Okay, so we will do some kind of refining here. Okay, so we will just do some kind of refining, because I have some minus x here and minus x here and minus x here. So I'll do some kind of refining so that my equation look better. Okay, so that refining I'll do here. So this thing I'll just write it down as it is. X square, it's positive only, so let it be like that. Okay, what refining can I do from here? Now look at this. I can write this like, look at this minus minus. I can take out, I'll just open this main bracket, the whole square. I can take out what? Minus 1 common from here, and I can write this as x plus 1.
X plus 1.
Because I'm just trying to make sure that the leading coefficient over here, not the leading coefficient, but the coefficient for this x is basically positive. How can I make this positive? I'll just have to take out minus 1 common from here. So when I expand this, how can I write this? Now since this is in bracket, so it's like I can write down minus 1 the whole
Minus
square
1 whole
and
square
x
equals
plus
to
1
x
the whole
plus
square.
1.
What is minus 1 the whole square? What does this gives me?
1.
X plus 1 cover.
1. So I can write this as x plus 1 the whole square. So essentially, instead of writing this, I can write this, right? All of you clear?
Yes.
If it is not clear, watch this video again. It will be clear. But I will not be entertaining doubts like this here.
X minus
Okay?
4.
So now again, I'll come to this part. Again, I'm trying to make sure the coefficient of x is positive. So what I can do, I can just take out minus x from minus 1 from here. So x becomes positive. Since I'm taking minus 1, then I have to make sure that this is minus 4. Why? Because when I multiply with this, this has to be positive, right? Then only this expression will come. So now I'll just simply expand this and the whole, not whole square, but to the power of 10. Okay, so now what if I simply take out this and I simplify this? So this is going to be minus 1 to the power of 10 and x minus 4 the whole to the power of 10. So minus 1 to the power of 10 is what? 1.
Even so,
Right?
1 positive.
Because minus 1 into minus 1 minus, so we multiply 10 times, it will be
1. It will be positive 1. So essentially I can write this as what? X minus 4 the whole to the power of 10. So I can refine this and I can write this as x minus 4 the whole to the power of 10. Now again same thing I'll try to do here. Now what, again I have to make sure this, I want to make sure that this is positive. So what I do is I'll just take out minus 1 common from here. So this will be x minus 5 the whole cube, right? So now tell me what is minus
Minus 1.
minus 5 the whole cube.
Minus 1.
So what will this give me? This will give me minus 1 and this will give me x minus 5 the whole cube. So essentially I have to write like this, minus 1 and x minus 5 the whole cube. Now what, this is minus and this is minus. So if I multiply these together, what does this becomes? It becomes plus. So it will be 1 by 100 x square x plus 1 the whole square x minus 4 to the power of 10 and x minus 5 the whole cube, right? So this is all fine till now, all okay?
Yes, sir.
Okay.
Yes,
If you have doubt like, okay, how are you writing this, please watch this video again. I'm not going to entertain these kind of doubts like this. And if you have doubt, you can watch my week 4 session. I have elaborately discussed this. Okay, so you can do this. But for time being, now what? Now since we have refined this, now we have very nice leading coefficients, not leading coefficient, but the coefficients for this x being positive. Now I know how to draw the graph. Now the next question is our step starts. So what is the degree of this coefficient?
17.
Oh, not coefficient. What is the degree of this f of x?
17.
17. Is it even or odd?
Odd.
I'm just that it is odd. What about step?
Leading coefficient is positive.
Coefficient is positive.
Positive.
Odd
So
meaning?
odd means that whole function is odd.
So degree of f of x is odd.
Not function is odd.
The degree of f of x is 17, which is odd. Now understood? Now,
Yes.
what about this?
Yes, sir.
Okay, leading coefficient is what? Positive or negative?
Positive.
Positive.
So leading coefficient is
Positive.
positive. Well, very nice. Now what is the next step? Step
Roots.
number 3.
Roots.
Okay.
4 roots.
So what are those roots?
0, minus 1,
1,
You
4,
will have to
5.
look here, okay? Do not look here. Do not look here. Look over here. Now this is my function, okay? So what is the root?
0, minus 1, 4 and 5.
4
Plus
and
5.
5. So there are 4 roots, okay? So now since there are 4 roots, now the next step is, now you understood, first of all, it is an odd degree and it is positive. So now just recall the cubic function, how will the graph was like this, right? Something is happening in between.
Yes, sir.
Right? So something is happening in between. So this is how it's going to be. Basically, the nature of the curves remain the same. And these roots are playing some role which is happening, which is affecting inside. And that is why we get some bends and curves in between. But the nature of curves remain the same. Okay. So now what? I'll simply draw the curve like this. I'm least bothered what is happening at each end. But now what? I will just write down what are those roots. So what is the least root that I have?
Minus 1.
I have minus 1. And what is the most root value that I have? 5, right? And I can list out the other ones, which is 0 and 4. Okay. So what is multiplicity of minus 1?
Even.
2. Even.
Not okay. You can tell me even odd. What is the multiplicity? It's even. So it is 2. So what will happen over here? This thing
Will bounce back.
will go, but it will not cross. It will bounce back. What is multiplicity of 0?
0,
2.
This curve will try to go to the x-axis, but again bounce back. What is multiplicity for 4?
Even.
10.
Even again.
10 and even.
So even again, it will bend like this. It will be very steeper, as you know, but again, the nature remains the same. What is the multiplicity of 5?
Odd.
3 and odd.
Which is odd.
Cross.
So this will cross, but
cross
in a
like
slightly
this.
bent fashion, right? It will go in a slightly bent fashion like this, right?
Sir,
So this
at
is the curve.
4. Sir, at 4, it will make the graph will steeper or the graph will wider.
It will be steeper only, but basically it will be more steeper like this, but the nature of the curve remains the same.
Doesn't
Okay.
matter.
So now understand this. One more thing before going further. Just a minute. Not now, I told, right? We'll take that out at the end. So now, if this was my f of x and I had written this minus, this was 1 by 100. Okay. So now if I have to tell, okay, what if it is not 1 by 100? What if it is 1 by some 1 lakh or something? and the everything remains the same. These roots remains the same. What if it is the leading coefficient is like this? You know what will happen at that point of time? This curves might vary. So it is going to be something like this. It might be steeper here. It might be very, very large value here, or it might go very sharp here like this. You never know, it might cross like this, go like this, very steeper, and again go bend like this and then go. Okay. This is what you will have. But the
Dynamic will be
nature,
same, right?
just a minute. But what will happen is that this characteristics of this curve remains the same. This leading coefficient is something which is determining whether this is going very sharp end, or like whether this is more flatter, or whether this is like this just so much, and you know whether this is going very, very deeper. Let's say some value is like very big value. Okay, so that is something determined by this leading coefficient, but the characteristics of the curve remains the same. Okay, so now clear?
So your voice is cutting. Can you repeat?
Yes, it's clear now.
Should be clear now. Is it okay?
Sir, does this really matter while we are drawing the graph?
No, it does not matter.
Okay, fine. Thank you.
Okay, so that is all that we have to know from here. Okay, so now a quick question. Okay, so now I'll just take up some of your questions, and then I have 2 questions for you which you have to answer.
Sir, you didn't tell us about the increasing and decreasing.
I'll come to that. That is something you will have to tell me, because you should also know something, right?
Yes, sir. I think
I'll
sir,
just
we should.
Sir, how will you define that? How many turns the graph have?
Turning
without
Where
drawing
the slope is 0, you can tell.
Okay, so these are like subsequent terms. Till now, you don't have any problem with drawing the graph, right?
Yes.
No,
Nobody
sir.
has
I
problem
think
with
sir,
drawing.
we should further build questions on this question.
Sir, I have a question, sir. Looking from the graph, when it bounces, we can only tell that it is a even multiplicity, right? But depending on the steepness or the widerness or something, we cannot say exactly it is 2 or 4.
Exactly. You're right. Okay. Is there any other doubt just on graphics?
Like the qualifier, we will not be expected to tell exactly like it is 2 multiplicity or 4, right?
Yes. Okay.
So the
Just
maximum
tell me
turning
whether
point
do you have.
for a graph. Hello, sir. So maximum turning point for a graph is always equal to or less than the degree of the graph, right?
Yeah.
It is less than.
Less than, not equal to.
No, sir. Not equal.
Okay, less than. Okay.
Less than. Okay. So now my question is, do you have any doubt in drawing the graph?
No,
Okay. So one quick question to all of you. Okay. So now let's say if I have a function like this, x minus 1 and x minus 5. What is the graph for this? Okay. So first of all, it is even or odd? What is it? Even or odd?
Even.
The leading coefficient positive or negative? Positive.
Positive.
Curve looks like something like this.
So it will be an upward.
Something is happening in between. What is this?
Yes, sir.
This is what?
This is 2.
One.
This is not the right thing.
Yes, sir. On the
Yeah.
positive
So
side.
basically, it's going to be something like this, right?
Yes, sir.
What is the root?
1 and 5.
One root.
1 and 5. 1 and 5.
And what is the multiplicity of 1?
Odd multiplicity.
And what about the multiplicity of 5? 1.
Odd.
That is
Cross.
So
Cross
this
side.
is how you will get.
Cross.
Okay? Clear?
Yes, sir.
Now,
So
now
here
we
turning
are
point
at
will be 1.
turning point will be 1.
1 degree is 2.
Turning point. How did you come to turning point? Okay, fine.
We had turning points.
Yes, fine. I'll come to that part in a while. But as if now, I assume that you don't have problem in drawing the graph, right? Right?
Yes,
I
sir.
assume that?
Yes.
Okay,
Yes,
very
sir.
nice.
Yes, sir.
Then can you quickly solve these and tell me? Can you draw the graph for this? And let's come to these kind of questions and then we can entertain them. Right? Because these are the type of questions that can be asked, right? And I think we are up with our time because it's already 10. And I think we started 10 minutes late. But I will be extending till 10:30. Fine?
No issue, sir. Please extend.
We have more
It's
in
dinner time.
Fine. So all of you, but we can just wind it up by 10:30. I think I can cover it up by then. Okay. So now look at this, but maybe I'll just discuss some of the things at the end.
If
you let me
solve
speak, then
first.
Because if you ask me doubts and all, then it will get into Q&A type of session and it will not go that way. Okay, so now
when we can't understand anything, sir. Today's section is good, sir. Yesterday so much thinking and
all right, no problem. So now look at this. Consider a polynomial function, which is something given here. Okay, this is the polynomial function given. Now I think you can simply draw the graph, and we have to address these kind of questions. Okay, so now
The option number A and C is the correct.
A and C. Okay, so I'll just mark. All of you can
A
put
and
your
C are
answers in
correct,
the
sir.
chat window. I'll just check theirs. Okay, so you
Okay,
can
okay.
put your answers in the chat window.
Okay, sir.
Meanwhile, for others who is
Is
actually
Q considered as
waiting
a
for me to
turning
draw
point?
this, I'll come to that. I'll discuss all that thing here. Okay, so I'll discuss all that thing. Okay, so now look at this function f of x, which is given here. No, it's not f of x, it's p of x. Okay, so look at this function p of x. Now, okay, so what was our step number 1? First of all, do I have to do any refining here? Let's check this.
No.
I think so we have to do
No,
any
sir.
refining here. Okay, so could you tell me what is step 1? Step 1 tells you what?
Degree,
What is that
degree.
degree? Could you tell me what is a degree?
10.
10.
I think all of you are very pro now,
10.
right? So it's like 10. Right? So degree is 10. Okay, so what is step number 2?
Leading
Sir,
coefficient is
Leading
negative.
coefficient is
negative.
Coefficient is positive or negative?
Negative.
Negative.
Look carefully. It is negative or positive because this will ruin everything, right?
Negative.
Yeah.
Negative. Leading coefficient negative.
negative.
Positive or negative number 3. What are the roots?
Negative. 1.
Oh yeah, fine. I got it.
1, 2, 3, 4.
Sir, someone has two speakers.
I'll mute all. Fine. I got it.
Sir, someone has two speakers.
All right. So step number 3, what are the roots?
Sir, 1.
Tell me all the roots.
-1.
-2, -1, 1, 2, 3, 4.
-1,
Minus
-1, 2, 3,
3,
4.
4,
about
minus
zero?
1, minus 2.
And sir, 0.
Don't forget
0.
this. There will be
Yes, sir,
somewhere
0.
X, which will again destroy everything. So definitely, if you just miss out that 0, it's done. You will draw, even though you know the graphing, but you will not draw proper graph, right? So how many roots do we have? 1, 2, 3, 4, 5, 6, 7. Right? So altogether 7. Okay, so the next step is to draw this graph, right? So now if I have to draw this properly, okay. So now first of all, this is degree 10 and this is negative. So how will this be? This way, right? Right?
Yes.
A parabola
Yes,
downward
sir.
type and something is happening in between, right? Because of these
Yes, sir.
roots. Okay, so what is the least root value? -2. Then I have -1. Then I have 0. Then I have 1, 2, 3, 4.
1, 2, 3, 4.
1, 2, 3. Let's say this is 4. Though this thing is not up to the scale, but still. Okay, so fine. These are the things that we have. Okay, now what?
You left -1. Sir.
Okay, so now what more? Now let's just discuss this. Okay, at -2, what is the multiplicity of -2?
Sir, even degree.
Even degree.
Even
So
degree,
it will
sir.
bounce back, right? Okay,
Bounce
and
back.
this was -1, right? Okay, so what is a multiplicity of -1?
Very odd.
1. Linear terms.
Okay, so I'll just draw like this, and this is going to go linear, so it will just cross like this, right? In a linear fashion. Okay, what is the multiplicity of 0?
Linear, sir.
Linear. So
sir,
again,
1.
come here and it'll bounce. It will cross it in a linear
I
fashion.
think everyone knows now you draw it fastly.
Okay, fine. So maybe this is now at 1. What is the multiplicity? 1. At 2.
Linear.
No,
At
sir. Bounce back. Sir.
No.
Bounce back.
Bounce.
Bounce back, sir.
Bounce back.
At 3.
Again
Bounce
bounce.
back.
Yes, sir, bounce back.
At 4.
Linear.
Sir,
Linear.
Linear. So it will go like this, right? So this is what the curve is. Okay. So now this is how we get. Now this function p of x is, first of all, let's address this question. Okay. And let me see chat window who all have given what all answer first. Okay. AC, CD. Okay. Okay, so nobody gave answer. Okay, so in the beginning they gave AC, AC, AC. Okay, so very few people have given answers. So are you not with me, or like you forgot to give answers?
We are typing in the chat box.
We can't able to approach the speed.
Sorry, what? You cannot?
We can't able to approach the speed.
Okay. A, B, C, Vishwajit Roy say A, B, C, A, C, A, B, C, A, C. Forgot. Who is this forgot? Nishant, you forgot. A, B, C, A, C. Okay, fine. A, B, D. Okay, so some diverse answers. Let's see how is this diverse. First of all, P of X is 1, function in minus infinity to 2. Now let's just understand this. Where is minus infinity and where is 2 here, right? So minus infinity to 2 is all this region. So maybe I'll just use different color.
Horizontal line.
Yeah, so I'll just use a different color. So yeah, that this is fine. So basically, this is all the region which we are talking about.
Yes.
This all regions. And what is the other thing that they are telling? 4 to infinity. Where is this 4? 4 to infinity. Okay, fine. So now what I'll try to do here is, I will just simply draw a horizontal line here, right? And which all regions that I have to take?
Minus infinity to?
That's it.
Minus 2.
I cannot draw another horizontal line here. From here I can draw, but right?
Yeah.
You know that this was actually going like this. This curve was going like this. How many places does it touches?
1.
2.
Just X.
Right?
Yes.
There are 2 places.
It's not a one-to-one.
But we can't extend it, right? Matlab, it is not in between
You
minus
can
2 to
extend
4.
this. It says no in union. So I'm just taking from here. It's the same horizontal line, but okay, it was not defined here. But again, it was defined from here, no? So that is why we drew this. Right?
So it's
if
not
you have to.
Not
Not
1,
1 to 1.
So
Yeah,
it's
it's
not
not
1.
1 to 1. So this is not 1 to 1 function
I
because
think
you
this
see,
question is
if I
also
draw,
asked
because
in
this is how
Shalom.
I'm permitted to draw horizontal line from this only, right? This is my domain for my, I'm restricting my domain, right? So if I have to draw a horizontal line, I can draw only from this to this, right? So from this, when I draw and from when I extend the same thing over here, I see that it touches at 2 points, and therefore this is not 1 to 1 function in this domain.
Got
In
it.
this ring. Okay, so now total number of turning points. Let's get into this turning point. So many people have worked on this.
It's
Okay?
9. It's 9, sir.
Okay.
Nine.
Now let's
9,
count
yeah.
this.
9 turning points.
Okay,
9,
okay.
sir.
Great. All of you can say this. Well, let's see this. Total number of turning points. So turning points are nothing but
Yes, slope is
basically,
0.
basically the slope. No. Slope is not 0. It's basically an interval where the slope changes in the sense the sign of the slope changes. Essentially, this region is something where you will see the slope is positive,
But the
goes to
slope is
0,
also 0.
and it goes to negative, right? So what is happening? Basically, a turning point is characterized by 3 things. First of all, what you will have is basically the slope is changing its what do you say this? Changing
Direction.
its sign, or it's changing its direction.
Behavior.
Let's take it with the sign. It's changing its sign, right? And it is often accompanied with 0, right? The slope being 0, it is often accompanied with 0, because look at the slope over here, positive, 0, and then it becomes negative, right? So this is what is called as turning point. So you can also have turning point like this. You can
Means
also have
turning means
no,
turning
just a
point
minute,
is
just a minute. Now this is another point which I'm considering. Now look at this. What is the slope over here? Negative. Slope over here is 0, and slope over here is positive. So what is happening when I take a smaller interval? In that smaller interval, the sign of the slope must change, and that sign is often accompanied with the 0. Like it is always accompanied with the slope 0, right? So now which are those places? So the places
Why
are,
0 is not only the sufficient condition?
sorry?
Why slope 0 is not
The
only
number
the
of times it is alternating between the maximum and minimum, the function.
Correct. Okay, no, I don't know. I
Turning
didn't
point is
get that
basically
part.
degree minus 1.
Sorry, what? Simply, if you
Turning
will not
point
get
is equal to
anything,
degree
okay,
minus 1.
as if now, okay, fine. Let's not get into this turning point more. As if now, just understand turning points are all that wherever the vertex points of these
Bends,
mini
wherever the
parabolas.
bends are there, curves are there.
Wherever there are bends. That's it.
Okay, fine.
We will talk this thing more
Sir,
in the
also from
calculus
this
part.
understanding, there is no turning point for x cube, right?
Exactly. That is why you would see there is no x cube, and that is why I was not discussing you in the previous examples, because I had x cube and you can counter me there. You will tell me, yeah, this is x cube, right? It's a saddle point, right? So that is why you will see whenever, that is one more hint that you can say is whenever there is a x cube, you will not have that thing coming up. Well, that's out of context here, and that is why this becomes a valid question.
So x to the power odd is not
Forget
a
about all that
turning
thing.
point.
Forget about all that things. All that things we will
X
discuss
cube is
more
counted
on
in
that on the
turning
calculus
point.
part. Pay attention, whatever I'm telling you. Wherever you see this vertex-like structure, right? Wherever you see this vertex-like, which are those? Here, 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 and here. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 9 turning points.
Yes, sir.
Right? So these are the one which is turning points. And wait, let me complete. Look at this. Understand this. We understood that, when we were talking about this parabola opening upward or downward, right? At the vertex, the slope was being 0. Over here also it will happen. Look at this point. What will be the slope? 0. At this point, slope will be 0. At this point, slope will be 0. At this point, slope will be 0. So all that places which are the turning points, there the slope will be 0, right? Can we say this? So the other way of asking total number of turning point of P of X is 9. The other way I can say that in total there are 9 places where the slope of P of X is 0. Right? Is that a right statement? Yes, that is a right statement. Again, it is totally depending on the equation. And one thing that you can notice is there is the multiplicity of, okay, fine. Let's not get into that part. But trust me, this turning point is something we can discuss more when we are in the calculus part. Okay.
Sir, in X cube, sir.
Everything, because I need some calculus tool to explain you there. Whenever I'm talking slope, it doesn't make sense. Sure.
Turning point is equal to degree minus 1, right? That was this in lecture or something.
Right, it is in lecture.
Okay.
It's degree minus
It is not
1
degree
plus
minus
It is the
even
total
0.
number of turning points.
Less,
Basically.
It is
less
less
than
than
equal
the
to
degree. Less than the
minus
degree.
1.
Less than
Degree
equal
minus.
to degree minus 1.
Yeah, less than the
No,
degree.
see, that is only the maximum turning point. It cannot be,
Correct.
always degree minus 1.
Right.
Because X cube does not have a turning point.
Exactly.
Yes, yeah.
Okay.
So
now let's come to the other thing. No, wait. Yes.
The last point.
Let me complete these two options and then we can take up your doubts. Okay. So P of X is strictly decreasing when X is between 4 to infinity. Where is this 4 to infinity? This is that region, right?
Yes.
Yes,
I'll
sir,
take
it is
up doubts
decreasing.
in a while. So look at this. Is this strictly decreasing?
Yes.
Yes, sir.
So this
Yes,
is right.
sir.
Okay.
Yes, sir.
There are exactly 9 points on P of X where the slope of the tangent can be 0. So is this right or wrong?
Yes, sir.
Right,
Yes, sir.
right.
So what are the right answers then?
Correct.
B,
B, C, D.
D. Okay, so these are the answers. So those whoever have selected A as the answer and any of the two, you will get 0 marks, right? You know this is how MSQ works, isn't it? If you select even one incorrect, option, your entire
Sir,
marks is equal to 0.
is there not is there a partial marking thing, sir? Like,
There is a partial marking. If you're not choosing incorrect, let's say among these two you selected just this one and you left it, you will get a partial marks.
Okay.
Sir, option, sir, can you explain option C?
Do we have negative marking, sir?
No negative marking.
So what will happen if we don't write any answer? Is there any deduction?
0 marks.
0 marks.
Even if you attempt anything, you will get 0 marks. So it is better you attempt, right? You don't leave.
I have a query, sir.
Okay, so first of all, let me just tell this. Somebody asked me, why is this strictly decreasing, right?
Yes, sir.
Yeah. So why is it strictly decreasing? Look at this function. What happens as x increases? What is happening to your f of x? Increasing or decreasing?
Decreasing.
Decreasing.
That is why this is right answer. Okay. So now what do you mean by really strictly increasing and strictly decreasing? Now look at some examples which I'll give you. Look at one. This is one function. Okay. Now this is like a straight line over here. Let's say this is 5. Okay. Now this is not strictly increasing, though it is increasing, but it is not strictly increasing. Why? Because look at this. As you are going, look at this. If this was -2 and this was like 6, what is happening? Up to -2, it is definitely increasing, right? It is increasing. But from -2 to 6, what is happening? It is constant. After that, it is again increasing. Well, overall, this is increasing, but this is not strictly increasing. Okay? You understand now? So what do you mean by strictly increasing? Strictly increasing by name itself, you can understand. Just the counter of this. Okay? So now you understood this part? Okay.
First option,
Okay.
yes.
Sorry, what?
First option, why it is long.
But again, I mean, the strictly increasing or decreasing, it depends on the range, right? What we are talking about.
Again, yes, that is right.
A codomain, I think.
So when
I have a query, sir.
not the range, but yeah, what he told was definitely right. It depends upon the domain, in fact. So whatever is your domain, if I have to restrict the domain and then if I ask you, then it makes sense. Well, over here, when we are not telling you anything, it is from R to R. Okay. That is how you have to consider and go. All right. So before going further, what are the possible questions that we can ask you? Think. What more we can ask you? Other thing which we can ask you is, okay, the multiplicity of...
On to whether P of X is on to.
Whether P of X is on to. Okay, yeah, that is one thing that we can ask. Whether P of X is on to, is this right statement?
No, it's not on to.
Again, that is actually incorrect way of saying it because we don't know where these peaks are, right? Even we cannot frame questions like this.
Okay.
Isn't it?
This is not the right question.
But I'm pretty sure if it is an odd degree, I can say that yes, in that particular case.
Sir, we can ask like it is an even function or odd.
Now, no. Understand this. We can also ask it here. Is this onto? Well, this is a valid question again. If the degree is even, it can never be onto. Now, I'll just summarize it here. If a function, now look at this function. This is defined from R to R. Okay. Okay.
Okay.
Now look at this. If the polynomial is of, let's say, something is happening here and it goes like this. Okay. If it is, so what is the degree of this? If this is the thing, even or odd?
Odd.
So this value is continuously increasing and this value is continuously increasing. I mean, it is actually overall increasing only. It's not decreasing. You cannot say that.
It is on to I.
So in this case, what is the range?
The range is R.
Minus infinity to plus infinity.
Yes, the range is R basically.
On to infinity.
Yes, but in this particular case, when the endings are on the same side, right? How big that peak can be? Can you tell me? There is somewhere where it has got its limitations, right?
Maximum.
Yes, exactly. So well, that in that case here, this can never be onto.
Right.
Right.
But sir, it again depends on the codomain.
How codomain or domain?
Codomain is defined.
Codomain is something it is always given, and codomain is nothing to do. Codomain is only to ask whether it is onto or not.
So in this question, it depends on the
That's why you are
codomain.
saying that degree is even. It is not.
It is never onto. Yeah.
Yes.
If the function is defined from R to R, and if the degree is odd and the function is defined from R to R, then it is definitely onto. So I'll just mute all.
Right. So of course,
Sir, can you please?
Yes. I have muted all. Okay, I'll mute you again, all of you.
So can you please repeat the statement?
Okay. Fine. So now, if the degree is odd, now for now, just this is the highlight thing that I'm telling you. If a function is defined from R to R, okay, like this is a general statement. You can make a note of this. If a polynomial function defined from R to R, okay, and if it is an odd degree polynomial, then it is an onto function because the range will be R and the codomain will be R. And the codomain is R, which is already given. Okay, and look at this. Now the next statement is a polynomial function defined from R to R, and if it is an even degree, right? If it is an even degree, it is never an onto, right? Right? It is never an onto because the range is some significant value, but the codomain is R. Okay, so this is all that you have to understand from here. Now, this is all that you can think of. All right. Now, one quick question to all of you. Over here, this one-to-one function in that interval. Okay, fine. Not a quick question here, but I'll ask you one word problem, and that word problem is very important. And with this, we'll just end our question. We'll end with this. And if you have, and if see, this is one question which I'm giving you right now. Just try to solve this particular question, okay? And just give importance to your week one, especially relations, types of relations, okay? And if you have any doubt in types of relation, maybe I can just show you for like, you know, like some 10 minutes or something, maybe just a recap of what it is. Just what are the types of relation, that is very, very important, okay? So just pay attention for that part, okay? At least type of relations are very, very important, fine? So pay attention to that thing. If you have any problem, like if you have any doubt, I can just, after this question, I can just show that slide where I can show you all the things, maybe you can see, and I can just tell you what all these things are, and we can just end our session thereafter.
Sir, one doubt, sir. Is an even degree polynomial said to be even function?
Sorry, what?
No, when is
it's
a
not
function
even.
even or odd?
Even or odd?
It depends on the
When f of
degree, or
when
F of x
minus
is equals
when do your
to
function is even, and when do you say a function is odd?
f of x is equal to f of
when
minus x.
Right.
Is
When
even.
f of
when
x
it
is
is
equals
even.
to,
Okay.
or maybe when f of minus
X is
this
equals
is
to minus
happening,
of
then
of
you say
x.
this is even function,
Even, okay.
can
and this
check
is
it by
symmetric about
graph.
y-axis.
Yes, sir.
So basically, when some question like this comes, we'll have to substitute minus value for x and plus value for x and check whether the answer is
Correct.
Okay.
Or by looking at the graph also, you can say.
Okay, yeah.
Yeah.
Looking at the graph, is it?
Yeah, you can say that.
If there is a symmetry, then it is even.
Okay, fine.
Symmetric about y and symmetric about origin. Okay, so this
So
is one
what will be
question.
the behavior of odd function in the graph?
It'll be symmetric about origin. It'll be something like this, because see, this is x cube. This is how it is going to look like.
And sir, when do we say when it is neither even nor odd?
Neither even nor odd, when both of these conditions are not satisfied. For an example,
Abstract
if I have
type.
to draw now, if I have to draw one graph like this.
Snake type.
If I have to draw a graph like this, is this symmetric about y-axis? No, since this is not symmetric about y-axis, it is not even. Is this symmetric
So it
about
is symmetric about origin, I think.
No,
it is not an odd function. Therefore, this is neither odd nor odd even.
Can you
Okay,
please
well,
explain
keep
this
that
question?
aside. Keep that aside. Come to this part, okay? Let's say
Right.
Captain Levi. Okay, so I just don't want you to write Levi. Let's say Captain Levi wrote 15 assignments. Okay, not Captain Levi, but just keep it as Levi. And this is our question. So Levi wrote 15 assignments. His score in each assignment, R of n, is represented as R of n is equals to so and so. Okay, where n represents the assignment number, where n is from 1 to 15. Okay, and it is all integer value, as you can see, right? He wrote he should score 40 or above in order to pass the assignment. In total, how many assignment did Levi pass? Okay, so this is the question. How do you approach this question? First of all, R of n is given to me, and R of n is given like this, n square. What I'll do is I'll simply take out this 1 by 1000.
The function is negative.
N square.
Is
Yeah,
zero
just a minute. Yes. And this is n minus 7, n minus 13, n minus 15, and there is something 40 it is given, right? So what they are saying, when R of as per the statement, Levi, when will he pass? When it is 40 or above, right? So R of n should be greater than or equals to
10 or equal to 40.
So I can also say R of n should, if it is R of n minus 40 is greater than or equals to 0.
Yes.
Right? I can say this if this is the condition which is applying. So that means if I have to modify this equation, R of n, and if I take this 40 to this side, left hand side, this will become like this. And now what I have left with? I'm left with all these factors, right? Right?
Yes, sir.
Minus 13, and this is n minus 15.
Something
Now what
like
I have
this
to make
is
sure,
not
now let me say this is another thing. I have to make sure that all of these value is greater than or equals to
0,
right? So I have to make sure that this is greater than or equals to 0. So all I can do is just draw the graph for this, right? So let me quickly draw the graph for you. This is 2. and how many? 1, 2, 3, 4. 4 plus 2 makes it 6. And what is this is positive. So what? I know that this is going to be something like this, right? What are the roots?
3,
0,
7, 13,
3,
or 15.
7,
13,
13 and 15. All I have to do is just simply cross it, because multiplicity for every multiplicity of 0 is what?
Sir, at 0 it will bounce.
Even.
It is bouncing back
Even.
here, and then everywhere it is going like this, right?
Okay, so we will extract out the
So now we
positive
have to
part.
make sure wherever this is basically r of n minus 40, right? This curve represent this only, na? Now we have to
Right.
make sure where all
Yes.
this is positive or equal to 0. So first of all, at 0, now since they are saying it starts with 1, so over here I can have 1, and at 2 I have these values. So what are those lists which is coming in? 1, 2, 3, yes, accepted. Why? Because greater than or equal, right, to 40, right? So 3 at 3 it will become 0. 0 means r of n is 40 at 3. Then what can I take? Can it goes in 4? Can I take 4?
No.
I cannot take 4 because when I take 4, r of n minus 40 is lesser than 0. That means it is becoming, I have to make sure it is greater than 0, right? I have to make sure that this is greater than or equals to 0. I cannot take that, but I can take 7 because it can be equal to 0, right?
Yeah.
When it is equal to 0, that means r of n is 40.
Please repeat the why
Okay, I'll
are
repeat this,
not
but first
considered
let
the
me list
4.
it.
First, let's
First let me
compare.
write it down. So 7, and then what? 8. I can
8.
write 9, 10, 11, 12.
10.
12, 13, yes. Then what? Anything more?
15.
After
15.
15, yes. 15. Is there any 16? No, I don't have 16. So how many
No.
assignments in total?
15.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in total, how many assignments did Levi pass? 11 assignments.
Sir, please explain how this
12.
Rn minus 40.
Sorry, 11.
11. Sorry, what? Please explain.
Rn minus 40.
Okay. So first of all, look at this. He should score. First of all, r of n gives you what? R of n gives you marks.
Sir, mic, sir. Check your mic, sir.
Okay. Now is it fine?
Yes,
Is it
sir.
fine? Okay. So now look at this. R of n. R of n should be what? R of n represents the score in the assignments, right? So R of n has to be what? Greater than or equals to 40. Right? Then only he will pass that assignment if it
Okay,
is
sir,
greater than or
got
equals
it.
to 40. So now what am I doing? I'm just
Rn
taking this
minus
40 to the
40
other
should
side.
be greater.
So now what? I have just drawn the graph for r of n minus 40, and I'm just making sure where all it is greater than or equal to 40.
Sir, is it a
Understood?
coincidence that it is given plus 40 in R of n already?
Sorry, what?
Like, is it a coincidence that R of n is like plus 40 is given in the function R of n, and we also have to calculate score above 40?
It's why do you say coincidence? The question is framed like this, like
if
make sure that you think this.
Okay, got it.
Yeah.
No, maybe sir, his question, if it is not 40 in the function, if it is not
Yes.
40, what do we
Right,
do?
if it is 60 or something else.
So do it same way.
What about 40, which is in question, plus 40?
I don't know if I understood his question. Okay, if it is here in this function, if it is 60 or something.
It is like 60 or 20. Then
Here, no? Here.
Yes.
Don't worry, we will not give you something like that because we are interested in you making the graph here.
Because
If you
graph
do
is
this,
not possible.
yeah, because that time the graph will not be right. And even if you have a slightly bending here, no, that becomes a complicated things to do, right? Which even nobody can solve that, right?
Right.
And
Yeah.
if it is minus 40?
Well, then you will have to, manipulate it accordingly and then see.
Okay.
See, yeah.
But I think it is in one of the practice assignments solution.
Yeah, correct. In some of the assignment, it is given like this, but this is just, I wanted to highlight it here that this is something that you can think of. Okay. So now, as I told you, now since it is timed up and I'm officially done with week 3 and 4. So one quick thing that I would like to tell is, so
Sir,
just
that
as I
from
told,
week
The
1 and
types of
2,
relation.
minute doubts are there.
where?
From week 1 to very minute doubt there, if
Tell
you
me.
can clear. Sir, please
Is it
take
related?
one set. Yes, yes. If one set A is there, that is having elements 1, 2, and 3. Okay. And the relation is defined over A cross A.
Okay. 1,
And
2, and 3.
Yes. This is set A. And one relation
What are the elements?
is
Tell me, yeah.
yes, 1, 1, and 2, 2.
1, 1, and 2, 2. Yeah.
So
Tell me.
is it reflexive?
No, it
Because
is not
one
reflexive. It is not.
Okay.
It must have 3 cross 3, 3 comma
3.
Okay,
Okay,
fine.
clear?
Okay,
And this
so
is it identity?
no.
Okay, fine. Thank
Okay.
you, sir.
It must have all the diagonal elements. So I hope
All.
all of you are okay with this.
So let's
Symmetric
stay with the.
relation.
Sir, in her question, I would like to add, if it is given like 1 1 also given, 2 2 also given, and 3 3 also given, so then will it be an identity relation?
Yes, it will be identity,
And
but it will
also
not be reflexive.
not be reflexive. Why, sir?
It will not be reflexive because, sorry, it will be reflexive as well. I'm so sorry. It will be reflexive.
It is the smallest reflexive.
Yes, it is the
And
smallest.
sir,
reflexive.
if
Sir,
we write
week 1 to 4.
A mod B means A divided by B, right?
A mod B, like this, A divided by B.
No,
A divides B.
No, MOD. If we write A, MOD B, it means A is
Can somebody
divided
tell
by
me?
B.
It's in week 1, division.
Yeah.
Okay, A is dividend, right? Fine.
Okay,
Thank you, sir.
do you want
Sir,
me
in
to?
week 1 to 4. Sir,
Okay.
just a small question. From week 1 to 4, you have shared a book, right? A revision book, kind of where it includes all the topics. There, in under transitive relation, you have given one relation, which I suppose is not transitive, but it is mentioned as transitive. Can I tell that relation for you?
Okay. You're a qualifier student or like?
Yes, qualified student.
Okay. Can you do one thing? Can you just highlight that in the forum so that we can take up and make the correction in the book accordingly? Is that fine?
Sure. Yes, sir. Thank you.
Yeah. So you see, I'm like officially done, and I don't think so. I should be repeating this because if I repeat this, it will take another half an hour. So what I would suggest,
Sir,
like
please
whatever.
tell, sir.
Okay.
Please just
Repeat
give
it,
one
sir.
example of asymmetric and anti-symmetric. Very
Yes,
much
sir.
confused.
Please.
Okay. Asymmetric and anti-symmetric.
Yes.
Okay, fine.
Once again, all, sir.
Once again, see, I'll tell you one thing. I'll tell you, I myself has taken this, okay? And in fact, this is the same page I have taken, okay? So if I have to take you to the slides, I mean, not the slides, but I'll tell you where that live session is, okay? You just see that because I have done it, and this is the most important thing. So
I
pay
think it
attention
is
to
in
this, okay? So I'll tell you where that is.
it is an extra life session.
So just a minute, I'll just tell you where that exactly is, okay? And then I can just formally end because it's already getting late. And I can just tell you some tips, the end tips that you can focus for your examination point of view. Fine. So I'll just
Yes,
open
sir.
the Seek portal, and because
Sir.
you will miss out all that other parts, which I could have told you anyways.
सर एक छोटा सा डाउट है क्वेश्चन में
कौन सी क्वेश्चन?
सर एक मैं बोल रहा हूँ द वैल्यू ऑफ क्वाड्रेटिक फंक्शन इंक्रीज ओवर द इंटरवल -∞ to -5 and decreases over the interval -5 to infinity.
Okay.
Also f of 0 equal f of -10 equal 20. सर उसके बाद में इसमें पूछा है कि कौन सा स्टेटमेंट ट्रू है?
पहले तो उस क्वेश्चन को आपको ग्राफ बनाना होगा.
Okay, sir.
है ना? Then it will become easy. Now just imagine it is saying that it increases, right? When you think of parabola, at some interval it increases, and from the vertex it start decreasing, right? So there is a clear indication where the vertex is. Okay.
Okay.
Yeah. So I'll just share my screen.
Thank you.
You can see that. And this is the last thing I would say, and I can just tell you like what all things that you should focus on, right?
Tips.
You can see my screen, right?
No, sir.
No, sir.
See my screen.
No, sir.
Okay. Now?
No, sir.
Yes, sir.
I think you should be able to.
Yes, sir. It is.
Yes, it's fine.
Yes, sir.
Now it's fine. Okay. So now come to this week 1, and under week 1, okay, not week 1. Basically, you go to these live sessions. there are, you can see these sessions here, right? Like activity, solve
All of
because
that
week
are
1.
not
This is
taken.
something we have taken last term, right? And I don't think so I have taken week 1 here live session. So this is like, which was discussed before. So it's me who is taking, it's me only who is taking this. So I have extensively covered here week 1, okay? And there are like 10, 12 examples that I have given, fine. So you would see this, that all these relations have been discussed here, okay? And there are some 10 to 12 examples that I'm discussing for each, at least 10, at least 5 to I have definitely discussed. So if you just go through this within 1 hour, just you can quickly go to what are these relations, okay? Like different type of relations. That will suffice the need, like it will cover everything, all your doubts. And even if I tell you something in this 15 minutes, that will be very injustice, I would tell you. Definitely, I will tell you that is very injustice. Because I might miss out certain things which you might not even recognize it. It takes time for me to explain, okay, what are these, each and everything, right?
Yes, sir, definitely.
Right? So,
Now,
Okay, sir.
so this is very important that whenever a concept is being discussed, you see it in all angles. What are, like, okay, if this is the thing you are telling, then what is the negation of it? Then you understand particular thing, right? So that is how I have discussed it here. I recommend all of you to, you can watch this video. Since I have taken this, so I know, okay, this is where I have this contents are. You have it elsewhere too. You might have it in other sessions also. Maybe you can just see there also if you want to. But since I have taken, I know that, okay, where that thing is, you can watch that and you can know that, okay, this is something you have to cover. Okay. So the last minute thing that I would like to say, we are not taking any more doubts now. This is the last
So
thing
it's
that I
not a
would like
doubt, sir.
skip
Just, I
slide.
mean, if you can give me just 1 minute, I'll just raise one of my concern.
Okay.
Okay. See, now regarding the asymmetric and the anti-symmetric function, the definition which you gave is not consistent with the definition which is described in the lecture.
Okay. The
And that
anti-symmetric
is
one?
what is making me confused.
Okay. So don't worry, you can follow either sir's or mine. Okay. The definition is definitely right. Okay. So it's just that.
No, that is right. See, what I'm trying to say is, for example, if you can just allow me 1 minute.
Yes, yes, yes.
If you say, I mean, you don't have time, then I'll not continue
No,
further.
you go ahead. Yeah.
Okay. So if, I mean, there is a set A which has got A, B, and C.
Okay.
Anti-symmetric is
Okay.
Go ahead. Yeah.
So if I'm doing a cross product A into A, I have AB and I have BC.
I have AB and BC. Yes.
BC.
Okay.
Now I need to have AC for this to be symmetric, right?
You need to have what?
I need to have, I mean, AB and BA, both are there, then it is called as symmetry.
Okay. AB and BA. No.
Yeah.
Symmetric. Yes, yes. Symmetric. Yes.
Symmetric.
What are you
Now,
talking about? Is it symmetric or anti-symmetric?
okay. Now I'm coming into the anti-symmetric part. If AB is there, then BA is not there. Then it is symmetric or I mean anti-symmetric or asymmetric.
Okay, you have just two elements, A comma B
Yes.
and
A comma B, just A comma B.
Just A comma B, it is anti-symmetric.
Then when it will be asymmetric?
When it will be asymmetric?
Yes.
This is also asymmetric.
Okay, so what is the basic difference then between asymmetric and anti-symmetric?
Okay.
Depends on how many elements.
Asymmetric, you will not have identity A comma A.
The definition, the particular definition itself.
Right.
The symmetric definition says what? If A comma B belongs to R, then you must have B comma A. That relation R. Do I have B comma A? Well, I don't have, therefore this is not, right? Now what about asymmetric relation? What is the definition it says? If A comma B belongs to R, then B comma A should not belongs to R. Right? Do I have B comma A here?
No.
Therefore, this is an therefore this is an asymmetric. I don't have at all. Right?
Sir, I can give you a better example if you can allow me for 1 minute.
Please, please.
Yeah, consider a relation with only one pair, 7, 7.
7, 7, okay.
It is not asymmetric because A comma B, that is 7, 7 belongs to
This
that
is not
relation.
asymmetric. That is
And-
definitely right.
Yeah, and the reverse, the 7, 7 is also
Exactly.
there. It is the
Exactly.
same, right? So this is
Yes.
not asymmetric. But
Exactly.
this is anti-symmetric. But this is anti-symmetric.
But this is anti-symmetric.
both-
Yes.
If
Okay.
A comma B and B comma A is also there, then A should be equal to B. That is anti-symmetric.
Exactly.
Hope
Well,
the person who is asking is now clear.
is that clear for you?
Yeah.
Is
Yes.
that clear?
I'm okay with it. Yeah.
Okay, fine.
Yes,
But see,
sir,
I would
sir,
still
even
tell
I have
if you.
faced this. I have faced this issue in your video. What the earlier videos of anti-symmetric relation, you have given 2 or 3 points stating that or our relation should contain single element or multiple elements. It was little confusing. But then, by referring some other sources and by extensive study, we got a clear idea. That video was
Okay.
little disturbing.
Okay, fine, no problem. So fine, if you have doubt over there, so maybe you can just put it in a discussion forum and then we can take it up. Okay, we'll do that.
Yes, sir.
All right. So even after watching
Yeah.
that videos, if you still face any difficulty, you can tell me. You can put it in the forum. We'll take it. Okay. So the final thing. So how you should really approach to your examination. So it should be like this. So basically, first of all, like you will have all the four papers, right? And one thing that I would like to say is, basically, we always have normal tendency if we have given a calculator, even if it is like simple multiplication, we opt for calculator, right? But if you don't have a practice of virtual calculator and you are applying it for the first time in your examination, that will kill your time. Understand this, right? For an example, if you want to just simply, it's like normal tendency. If I want to multiply some 11 times something, right? And if I have a calculator, I'll trust calculator over myself because we believe that, right? So what you should do is, but there is a click here, right? We are not used to this calculator thing, right? In your examination.
Yes, sir.
Isn't it? So if you don't have a habit of it and you have a given a limited time, why will you even use calculator for a simple thing? So avoid using it. I would say this. Even though calculator is there, that might mislead you and it will kill your time. Until or unless it is very much needed, then only use it. Okay.
So why don't you allow Windows calculator, sir? Because it's the same functions, right?
Yeah, I guess, yeah. But they have the TCS people, they have their own version of it, so they just
Because Windows we can use the keypad to type the numbers. Then.
Yeah, that's right, but they don't allow it like that. So that's why I'm telling you, because you're not used to that kind of calculator, so it might create a problem.
But for statistics and all, we need calculator.
Exactly. That is what I'm saying you. Until or unless it is must needed, do not go for it. Okay.
The tips for the exam, sir.
That's what I was telling. So now, first of all, let me complete these things. This one thing is very important. The other thing is, like whenever you are solving any kind of question, see when you are solving MCQ type of question, multiple select, until or unless you are very sure of an given option being correct, then only you choose it. Else, if you are not sure, like, okay, this might go wrong, if it is 50-50 chance, don't opt it. You will lose the entire marks, right? There is a high possibilities, right?
Okay.
So don't do that. Until or unless like you're very sure for that particular option, do not opt for that option. Okay. So that is something you should know. And one more thing, if there is an NAT type question, there are infinite ways of making error, right? There is infinite because you are entering some values in the system, right? Let's say you solve particular question and you got answer as 10. You never know, you will land up giving answer as -100 or -10 or something else, right? So you have possibility of making error everywhere when it is NAT type questions. So pay extra attention when you get something like this and enter the right value, right? And one more thing, there will be so many questions, okay? Like if there are some 15 question in mathematics, and if you, let's say you cannot solve any particular question, like this is very generic thing I'm telling you. There will be like first, you might get stuck in particular question, right? And you won't be able to solve and you're not moving further also. Do not do that mistake. First, glimpse through the question. See all the 10 questions or like 15 question or 17 question, whatever it is. Just go through all the questions. See which all things you can approach it in a very quicker way, right? Whichever is solvable very fast, just go for it, right? Solve it. Make sure, yeah, 50% of the questions are done. Now relax. Because you see, if it is like, let's say a graphing type questions, that is something you can do it in a minute, right? Tell me if it is wrong. It is not wrong. Yes, it depends. Like if it is directly asked or there is some context where you require thinking. But trust me, whatever I have done here, it's very much doable. Okay.
So there is no time split between the subject, right? These 4 hours we can spend in any subject, right?
Yes. You can spend in any subject. So you can opt for this. This is another advantage, right? Each subject I think
Sure,
is
I
1
have
hour.
I have
Okay,
also
so
two
let
more
me complete.
points.
Let me complete. Okay. So first of all, these are certain things that you have to keep it in your mind. Okay. Now coming to which week you should really focus on more, right? Of course, I told you week 2 and week 3 has got somewhat like 30% of weightage, right? And I'm claiming that week 1 is something which is very important. That means it has got some higher weightage than compared to week 2, right? So week 1 also becomes important. And I'm also emphasizing on the fact that the type of relations are very important, right? So pay attention to that, right? And another thing, of course, it's not just types of relation, but again functions is important. But these kind of things, but the things which I'm emphasizing, pay attention to this. Okay. When you come to week 2, what are the most important thing that you can do? It is all about, you have all set of questions, right? Not set of questions, but set of formulas. It is
SSC.
all about formulas. SSC, do not, do
Sir,
not think that SSC will be in week 2.
Sir, one thing also, sir, like in week 2, there are a lot of application-based questions.
Correct.
So,
That's what
are
I'm
we
saying.
going
You have to
Week
no,
2 and
just
3 is important for all subjects or only math?
I'm talking about just maths. So you see this as Pushkar. As Pushkar is telling, see, week 2 has got a lot of word problems, right? But week 2 has got the least weightage, right? So then what should be your strategy? If you have solved like 10 to 15 questions, it is not really mandatory that you should be solving every questions and going to your exam, because right now what you have to do is like you have to strategize it, right? As per your weeks, right? So whichever is your week, just opt for that, right? Like if I say that week 2 is, like these are the formulas will suffice the need, and if you have solved certain number of word problems, that is more than enough for week 2, right? So week 2 is all about this. Just memorize the formula. Week 3, whatever I have covered today, it is more than enough, right? It's like it was the whole revision. So week 2, what more we can ask in week 3? This is all given in your lecture also, right? We have just dissected it in all possible way, right? And it's just that word problem I did not give you. Let me complete this and then we can speak and then end the session, okay? So another thing is that we have to think about, okay, so that is something done. Now coming to week 4 again. Week 4 is very important in terms of graphing, right? And whatever we have done till now, and whatever we have taught you here, that is also, it's like we have almost covered like 90%, like, that is something I'm trying to say. So even if you see a question, you shall be able to answer that with the given knowledge what is provided today, or like whatever we have done it before. Okay. So pay attention to these things. Well, this is all from my end. Now you can tell me.
Sir, I have a small tip to all my fellow students. But
good,
the
good.
problem I have faced across in graded assignments or whatever assignment is, when we click on a numerical answer type question to enter some number, and after we finish entering our answer, and we scroll down our mouse to just to see the next questions, right? But if our cursor is not out of that numerical answer, the scroll will be applied to the numerical answer, and in that range the number will keep changing. What I'm trying to tell, yes, in the numerical answer, if I click and if I just scroll up, it will automatically become 1 2 3 4.
Sorry,
That bar is
also same.
All of you.
Same
if I scroll,
Yes, sir, right. It is the problem. So,
it is coming automatically.
Sorry to have faced that.
It is a HTML numeric field. That's why it is happening that way.
Yes, that numeric field is automatically, if I scroll down, it is decrementing the count, and if I scroll up, it is incrementing the count. So in a time-based situation, we may make this kind of mistakes.
We have to be mindful about that.
Just click outside the that.
Yes,
right. But she want to just highlight it so that others will know that this is what it's happening, and by mistake, if you are losing marks because of this, be extra alert, right? Yeah.
Yes.
So, thanks.
Sir, there is there's only one submit button, right, for all the papers, or is there any individual submit?
I think it will be. I don't know about that. You will get to know. I think it will be multiple or like.
Sir, and one more thing,
don't know
sir.
really about
Okay, then one more thing, sir. This factorizing the polynomial, that takes a long time. Is there any shortcut for that?
Yeah, so factorizing the polynomial definitely will give you the factors. Let's say
Yeah.
if it is 4-degree polynomial, we'll give you 2 roots for sure.
Okay, fine.
And so will we get
Paper and
sufficient
pen are allowed
rough
there?
pages?
Mhm.
Will we get sufficient rough pages as much as we want?
Yes.
Sir, and one more
And
thing. Yeah, please, you can.
Yeah, Preeti, go ahead.
yeah, sir, for the students above age of 50, they are giving 20 minutes per hour, means 1 hour 10 minutes in total extra.
I don't know that.
We got the mail today.
Okay, so maybe that would be right.
Sir, another
So the
non-subjective question, sir.
Mhm.
If I apply for 16 qualifier, if I fail or not or not absent, will be I able to attempt?
I'm sorry, Ram. I just missed it. Could you repeat again?
Sir, if I'm appearing for 16 qualifier day after tomorrow.
Yes.
If I fail or absent, I'm appearing again for reattempt. Will I be in the same batch as August to September or?
No, not same batch.
Sir, in the handbook it tells it's the same term, sir. The reattempt will be considered for the same term.
Will we have to reapply for that, or is it the same?
Yeah, there's 1,500. Again, we have to pay, and it
You
says.
should ask this to support team.
I think.
Yes, sir.
You
No,
better
sir.
confirm
Yes,
with
sir.
the-
No one is replying from the support team. Again, I'm asking you. Do you know anyone from the support team? Sir, I mailed for them. I have some medical issues regarding my leg.
Okay, Ram. So Ram, what you're a qualifier student, right?
Yes,
Put
sir.
it in the forum. I'll take it from there.
Okay, sir. Where, sir? Sir, where?
Maths forum.
Okay.
Sir, one more thing, sir. Like in graded assignments, wherein you can submit, press the submit button multiple times till the deadline. Do we have the same option here also?
I'm not sure of that, Radha.
There is no submit button here. Like it will
No,
be
sir, we don't
submitted
have that
when the
option.
time is over.
No. Submit button gets enabled by around 3:30. Then after that, can we,
Somebody
press
was also
multiple
asking like
times?
submit
for
once, then that
respective
will be the
courses,
end.
is there a submit button? So this is I'm not aware of.
Okay.
Sir, once you submit the application, will get closed, sir, because we are the students who have given the system compatibility test, means students out of India. Once you press the submit button, the application automatically gets closed.
Closed.
Don't have any
Okay.
option of changing your answers or
Yeah,
doing
Oh, I see.
something.
Then
I'm out of India. What you get when you get submit button, you get a chart, okay, where you will see how many questions you answered, how many
I see.
pending, how many you marked, okay. Then again you have one more button to submit. So you have three confirmation you are getting before finally submitting.
Oh, I see.
Okay.
Okay, I think you would have got some idea. Yeah, thanks, Jolish.
Thank you.
Okay,
Just,
so we can.
sorry, just so the 3 time you will get 3 time to submit. I mean, and you will see there whether you have answered wrong or right. Is this correct?
No, it won't tell you wrong because in the question you can mark it. Suppose if you want to review some question, you can mark it. So you will get a table once you click the submit where how many questions you answered, but you still needs to review it. You marked it. How many questions you have not attended. All the list will be there. So you need to make sure that everything is answered. Then if not, you can just on the bottom you can go back and again answer the question.
Okay.
Yeah. But submit will be one time only, right? Once you submit, you cannot resubmit again.
Basically,
It
it's
won't
a
be like
review.
a graded
No.
assignment. Yeah.
Because if you proceed further, then it will be done. Because from that point you need to come back. You should not go from the okay.
Yeah. Thanks.
Okay, great. So shall we end our session now?
Yes, sir.
So it's
Sir,
already.
please release one more mock test tomorrow.
We don't have we can.
So please take one session tomorrow.
I don't think so. We'll be able to take any more session, and you should actually do self-study now. You should do that because in maths it's about practice. If we keep taking session, it sounds good. Like yeah, I'm able to understand and everything that is at one place. But are you able to
Sir,
solve
you
the
are
paper? That
sir,
is the
you are
next thing.
100%. You are 100% right. When you teach, we are able to understand. But when you go for practice,
Yeah, that is different
it comes
altogether.
a lot of struggle.
that is what now at least give you one day time to yourself and try to solve it. Okay.
That is what I'm facing
Okay,
in
sir.
PT
Yes,
right
yes.
now.
Because this is what it happens. You try to solve because maths is about practice. It's not about listening and listening is just understanding. The next thing is completely on you. Right? So all the very best to all of you and
Thank you, sir.
put
Thank you,
as
sir.
many questions you want in the
Thank you very
forum.
much,
We'll
sir.
pick up your
Thank you,
questions.
sir.
Okay?
Thank you, sir.
Yeah. Thank you
Thank
all
you,
and
sir.
good night.
Registrar,
Thank you,
last
sir.
thing,
Good night. Thank you, sir. Good night.
Thank you, sir. Thank you very much.
please, if somebody have any question
Thank you, sir.
and
Go ahead. I'm listening.
but we don't have a time. Yeah, I mean, you are not taking any session, so just
Yeah, so I think it's already timed up. So we can just end it. You put it the questions in the forum. We'll take it from there.
yeah, okay.
Yeah.
Thank you,
Thank you
sir.
so much.
Bye. Good
Thanks
night.
Thank
for
you
all
all
this.
and good night. All the very best.
Thank you very much, sir.
Yes, sir.
Thank you, sir.
Thank you.
Sir,
Very nice session.
good night, sir.
Sir, discussion forum, where to submit it?
Good night to all.